adjacent to large environmental remediation activities or nuclear accident scenarios. And then we wrap up the day with a technical session looking at multi-scale modeling and upscaling. So it's an interesting agenda today. And I'm going to start right off with our case study and introduce our two panelists. And our first panelist is Juan Carlos Lentijo with and I'll try this in Spanish, Consejo de Seguridad Nuclear, which is the Spanish Nuclear Safety Council, and Mark Triplett, who is with Pacific Northwest National Laboratory. Juan Carlos, I'm going to turn it over to you. And I think you might still be on mute, Juan Carlos.
Yes. Can you
There we
hear me
go.
now?
Yes, we can.
Very
Thank
good.
you. Thank you.
Thank you, Karen. Well, dear colleagues, dear friends, good afternoon from Vienna, and very good morning or early morning in the US, and good late night in Japan. Thank you, all of you, for joining this session. And let me start by congratulating Pacific Northwest National Lab for its 2021 Global Summit on environmental remediation, and in particular for having included the environmental and remediation challenges following the Fukushima Daiichi accident as part of the case study 2, which is the focus of our session today. And I'm very pleased to co-moderate this with my good colleague Mark Triplett. Well, this discussion is especially relevant now, 10 years after the accident of Fukushima Daiichi nuclear power plant. Revisiting lessons learned from the implementation of the off-site remediation plans in Fukushima is, in my view, a necessary task for improving and optimizing those plans and their benefits to the local residents and, of course, to the whole community. In that context, let me summarize some elements of the case that, in my view, should have to be considered. Firstly, Japan moved forward very quickly and with the allocation of the necessary resources, legal, economic, and technological, to develop an efficient program for remediation. This was evident when we visited Japan in two occasions as part of the two international missions that the International Atomic Energy Agency conducted in 2011 and in 2013, focused on the off-site remediation efforts in Japan. I had the privilege to lead very experienced and dedicated teams of experts for these two missions. The Act on Special Measures was the key policy instrument to provide the necessary backstop to the implementation of remedial measures. It particularly stipulated roles and responsibilities, as well as the need for stakeholder involvement in the remediation process. In 2016, the agency conference on the commissioning and environmental remediation in Madrid recognized and highlighted the need to develop national policy, strategies, and means of dialogue for remediation of both legacy and post-accident sites containing residual radioactivity. Well, the response to the aftermath of the accident showed that the remediation has to be seen as part of the overall recovery, as part of the overall revitalization of the affected areas. While decisions need to consider a diverse range of aspects that include scientific, technical, and economical inputs, the social dimension is of particular relevance. Making decisions in such circumstances can be particularly challenging. Integrating public engagement into decision making concerning environmental remediation, particularly concerning the desired end states, is extremely complex, as you will know. The Madrid conference called the attention to the fact that it would be beneficial if guidance on decision making could be developed at international level. Finally, the aspect of knowledge management. All the collected experience needs to be captured and make available in case an unlikely similar event may happen in the future. In Japan, a big effort was put in place to organize and make available information from the previous events worldwide. A key aspect for the was in this sense the so-called pilot projects intended to apply a series of procedures to the conditions that were prevailing in Japan. Although different publications have been issued and so many events have been organized, what is relevant again is to organize all this into a framework and have it articulated in support to decision-making processes. This summit may wish to highlight and explore new avenues to contribute to achieving these important objectives. In concluding, let me also address the collaboration that the IAEA has established with Japan in relation to its remediation efforts of the offsite areas around Fukushima Daiichi nuclear power plant. In this regard, the agency has established two practical arrangements with Japan to assist the Fukushima prefecture in areas such as radiation monitoring, remediation, and decontamination, as well as radioactive waste management. This collaboration contributes both to facilitate international support and to disseminate lessons learned from the implementation of remediation in Japan to the whole international community. I thank you, and I hope that our session will be of great interest for all the attendees. Then, if you allow me, we can move to our first speaker, who is Seiji Osawa from Miyagi University. Until Seiji Osawa retired in July 2020, he was responsible for environmental restoration of the land within Fukushima Prefecture. Osawa has, from this perspective, first-hand knowledge of the remediation methods that have been applied in the communities affected by the nuclear accident. Now, with Miyagi University, Osawa's main interests include reconstruction following the nuclear disaster, revitalization, and tourism for of the disaster areas, including also risk communication and regional environmental policy. Then we have the privilege to receive, to give the floor to Mr. Osawa, who will deliver his speech about perspectives on planning long-term remediation of impacts of a nuclear accident. Mr. Seiji Osawa, please, the floor is yours.
Thank you, Chair. Dear colleagues, ladies and gentlemen, it's a great pleasure for me to have a presentation. My name is Seiji Ozawa. About 35 years ago, in 1986, I became a government officer when Chernobyl accident occurred. A quarter century later, we had Fukushima Daiichi accident. After the accident, I was dispatched to Fukushima. I've lived there for about 8 years. Last year, I moved to Miyagi University from Ministry of the Environment. At the beginning, I'd like to show you some pictures of scenery in Fukushima. This picture shows Fukushima City, where I've lived since 2012 to 2019. In Fukushima, we were enjoying beautiful blossom season in spring. This lake stands in the mountainsides of Fukushima City area. It supplies fresh water to the people in Fukushima City. At that time, every day, I've opened the tap and enjoyed its very cold and delicious water. The bottled tap water won the Mon Selection Gold Award for the 7th successive year since 2015 from the Belgian Citizens Organization. That honor was gained thanks to the efforts of the staff members of Fukushima's water supply organization, who have taken much care to supply clean water. After the accident, some people, especially who lived outside Fukushima, worried about using the water because mud at the bottom of the lake contained cesium. However, the water is safe because cesium is attached to soil particle and filtered out at the treatment plant. In addition, the water supply organization has been monitoring water every day to make sure there is no cesium. We are very proud of Fukushima's beautiful scenery and delicious water and food. We also want the young people in Fukushima to take pride in their hometown. In Fukushima, we have thousands of high school students. After graduation, many of them move from Fukushima to Tokyo, Kyoto, other countries to go to university or to work. Then they might be asked from people there, did you drink tap water in Fukushima? Did you eat rice produced in Fukushima? Was it safe? They contained cesium, didn't they? That is a big challenge now we need to think about. In Fukushima, lots of leaders, including mayors, medical doctors, and teachers, have been working to support the students that they can explain about the safety of water and food in Fukushima. About these maps, left side one is on April 2011. Right side one is on October 2016. The air dose rate reduced by 71% in 5.5 years. That means the reduction was faster than natural decay. Decontamination is one of the measures for radiation protection to remove radioactive materials from the inhabitation areas in order to promptly decrease impacts on human health and the environment. In right side map, for the colored area, decontamination was conducted by the government. It's named as a special decontamination area. These are the actual decontamination activities. We have adapted the most suitable techniques according to the respective conditions. Decontaminating roofing tiles by wiping. Decontaminating gardens by removing soil. Decontaminating a forest by removing fallen leaves. Through the work, we were able to see the effects of decontamination. In the graph, the air dose rates at the height of 1 meter from the ground are compared before and after decontamination. For example, in residential areas, we checked 203,000 points and confirmed that the air dose rates were decreased by 56% after decontamination, and also proved that the effect of whole area decontamination was maintained. Gray part on the map showed the area where the residents have difficulty in returning for a long time due to high air dose rates. In the other areas, whole area decontamination was conducted while discussing with respective municipalities and completed by the end of March 2017. Also, evacuation orders were lifted upon the progress of decontamination. In Fukushima Prefecture, large quantities of contaminated soil and waste have been generated from decontamination activities, and it is currently difficult to clarify methods of final disposal. That is why it is necessary to establish an interim storage facility to safely manage and store the soil and waste intensively until the final disposal. In the past, it was thought that the total estimate volume would be about 22 million cubic meters. However, now we confirm it would be 14 million cubic meters. This is the site for the planned interim storage facility. The left side is north, the right side is south, and the upside in the Pacific Ocean. The center is Fukushima Daiichi power plant. It's approximately 1,600 hectares in the whole area, and about 79% of the whole area is private property. As of the end of February 2017, government acquired about 24% of the whole plant site of the interim storage facility. Now, September 2021, Ministry of Environment acquired about 78% of the whole site. For the contamination work and constructing interim storage facility, we have had communication activities with local people. We have been making efforts for risk communication for the public to easily understand about various radioactive materials by making pamphlets and TV programs. I'd like to point Thanks Helmet campaign. We have had totally 13 million decontamination workers in special decontamination area. As thanks for them, elementary school and junior high school students made some messages. Thank you, the workers. We appreciate your activities. Take care. We want to come back to our hometown someday. It to motivate the decontamination workers and improve relationships between the residents and the workers. Again, I would like to show you some photographs of Fukushima. Peach, it's sweet, tasty, delicious. The agricultural organization and farmers in Fukushima conducted the contamination of peach trees. Cesium has not been detected from peach. Peach is a symbol of restoration. Some stories were written in old Japanese mythology. This is the last. Sorry. Again, sorry. This is the last photo. A blooming peach garden in Fukushima. In the earlier part of my presentation, I said that we are facing a big challenge, that we need to help students have a right notion of Fukushima. At the same time, I think that we also have a responsibility to have people in nodal areas such as Tokyo, Kyoto, other countries to know correctly about Fukushima situation and radiation. So everybody, participants, please give us your support for the big challenge. This concludes my presentation. Thank you for your attention.
Yeah. Thank you, Mr. Osawa, for your nice presentation. I think that Seiji is not with us because the late night in Japan. But in any case, I think we should appreciate his presentation, and especially I would highlight that from his presentation we have now a very good understanding of the great progress that remediation and revitalization is achieving in Japan, especially in agricultural areas. I would highlight also the good coordination, the need of coordination of several actors at a national, prefectural, and local level. And finally, I would also highlight the specific mention he provided about the need of working with the community of young people, students and children. Education is mainly maybe the main driver for social acceptance and social participation. So that this is my summary. I would like now to move to my colleague and co-moderator, Mark, who is, I forgot to mention before, Mark is also from Northwest Pacific National Lab. Mark, the floor is yours, please.
Okay, thank you, Juan Carlos. Yeah, one observation I'd like to make is it's pretty clear that this case study is very different from the other case studies, and that the contamination has had a very substantial impact on the lives of the people and the communities, and also on the viability of the community. So I think that's a theme that you will see throughout this case study, is the direct impact and the need for involvement of the actual people who were affected by the accident. So our next speaker is Mr. Yoshinori Momose, and he is a section chief with Japan's Ministry of the Environment, with overall responsibility for managing the decontamination waste that's been generated from remediation of the offsite areas. Mr. Momose is also overseeing several demonstration projects looking at methods for recycling and reuse of low-dose soil and decontamination materials, and with the overall goal being to minimize the total amount of contaminated material that needs final disposal. And for my Hanford colleagues, just by context, the total volume of material that we're talking about from the remediation waste is about 2 times Hanford's environmental restoration disposal facility. So it's a very large and long-term problem. And Mr. Momose is here in person, but we do have a recorded presentation from him, and he should be available at the late hour for some follow-up questions if there are any.
Hello, my name is Yoshinori Momose from the Ministry of the Environment of Japan. Thank you for giving me such a wonderful opportunity. I would like to announce what the Ministry of the Environment of Japan has been working on for recovery from the Fukushima Daiichi nuclear accident and remaining issues. First of all, the accident at the Fukushima Daiichi nuclear power station of Tokyo Electric Power Company 10 years ago causes environment pollution by radioactive materials. The figure on the left shows the radiation dose rate. It means the later it is, the higher it is. As a result, evacuation orders for residents were issued in the 12 municipalities in Fukushima Prefecture shown on the right. The decontamination work was implemented to reduce the air dose rate and restore the living environment. As you can see in this photo, we removed the soil with radioactive materials on residential area, farmland, and forest, and cleaned the surface of the road. As for the effects of decontamination work, for example, in the residential areas in the leftmost graph, the air dose rate is decreased by 60% on average by decontamination work. In addition, the subsequent monitoring investigation showed that the average dose rate was decreased up to 76% and the decontamination effect was maintained. As a result of the decontamination work, the air dose rate of Fukushima has been decreasing year by year. As shown here, it is now at almost the same level as major cities in the world. On the other hand, as a result of decontamination work, a large amount of removed soil was generated, and as shown in this photo, it was placed in a large black sandbag and temporarily placed in various parts of Fukushima Prefecture in order to accelerate the reconstruction work in Fukushima. Removed soil was transported to the interim storage facility. Interim storage facility is located in Okuma Town and Futaba Town. When accepting, the local residents made a difficult decision. The promise of final disposal outside Fukushima Prefecture within 30 years is the legal responsibility of the government. This takes into account the serious environmental damage and the heavy burden of residents in Fukushima. The amount of removed soil and waste transported to the interim storage facility is enormous, about 11 cups of Tokyo Dome. For the purpose of reducing the final disposal amount, recycling is the key. Of the removed soil transported to the interim storage facility, the policy is to recycle the soil with a low radioactivity concentration of 8,000 becquerels or less per kilogram, and finally dispose of high concentration products outside the prefecture. As a method of recycling, we would like to use it for embankment of well-managed public works and effectively utilize the removed soil on the premise of ensuring safety. Currently, 75% of soil is less than 8,000 becquerels, and by processing even higher concentrations, it is possible to increase the amount of soil that can be recycled. I will explain the recycling process. At first, removed soil was separated in each large container bag or less than 8,000 becquerels per kilogram and over 8,000 becquerels per kilogram. Then, to take out the soil, large container bags with removed soil less than 8,000 becquerels per kilogram are broken by machine. After that, plants and metals are removed by sieving machine, and there will be quality adjustment if necessary. After the confirmation of radioactive concentration, it will be used as a material for construction work and finally covered with mountain sand. I will explain the concept on safe use of the removed soil after recycling. The standard is to ensure that the additional radiation dose to the people engaged in the work and the surrounding residents should not exceed 1 millisievert per year. Japanese people are exposed to 2.1 millisievert per year from the natural environment, and if they undergo a CT scan at a medical examination, they are exposed to 5 to 10 millisievert. So the standard of 1 millisievert is sufficiently low compared to this. Since 2018, we have been conducting a recycling demonstration project at Nagado district of Itachi village, Fukushima prefecture, to confirm whether recycling can be carried out safely. Here, recycled materials are used to create farmland, and from fiscal 2019, we are cultivating resource crops and flowers, and from fiscal 2020, we are cultivating edible crops such as vegetables with the cooperation of the residents. In this demonstration project, we conducted cultivation experiments with various vegetables last year. As a result of measuring the radioactivity concentration in vegetables, it was 0.1 to 2.3 becquerels, which is sufficiently lower than the standard value of 100 becquerels of general foods. In addition, there was no increase of air dose rate and no detection of radioactive cesium from the seepage water. In addition, in order to promote understanding of recycling, we have used the removed soil for potted plants, planted foliage plants, and installed them in the minister's office since March last year. From July this year, it was set up at the Prime Minister's office. There was no change in the air dose rate before and after the potted plant is installed. I will summarize today's presentation. In order to remove radioactive materials released by the accident at Fukushima Daiichi nuclear power station of Tokyo Electric Power Company, we have been promoting the decontamination work that is unprecedented in the world. As a result, the dose in the living environment has been reduced to the almost same level as in major cities in the world. On the other hand, decontamination work has generated a large amount of removed soil. Currently, it is being transported to the interim storage facility in Fukushima Prefecture, but it will eventually be disposed of outside Fukushima Prefecture. For the reduction of the final disposal, recycling is the key. So, we are currently confirming the safety through the recycling demonstration project. We will take on the very difficult task of expanding recycling and realizing final disposal outside Fukushima in the future. This concludes my presentation today. Fukushima has a lot of delicious food and beautiful scenery. If you have a chance, please come and visit Fukushima. Thank you very much.
Thank you, Mr. Momose, for your presentation. I was wondering, if you're still with us, could you talk a little bit about what portion of the decontamination waste has been collected at the ISF so far? And if much remains, what is the expected schedule for completing the removal of the decontamination waste?
Okay. Can you hear me?
Yes.
Okay. Thank you for my presentation time. And thank you for questions. At first, the portion of waste is so about 80% waste is more than 8,000 becquerel per kilogram, but about 15 or 20%. Sorry, I misunderstand. Sorry. Sorry, about 80% is less than 8,000 becquerel per kilogram, and about 20% is over 8,000 becquerel per kilogram. So it means many amount, a large amount of soils waste are very low level. Yeah. And so next question, how long will it take to collect all materials at the ISF? Maybe, so we think the amount of waste is 1,400 cubic meters. Yeah, so just now we transfer to about over 1,000 cubic meters now. So next year, I almost end to the transfer to ISF. Is it okay?
Okay, thank you. Juan Carlos, did you have an additional follow-up question?
Not in particular, because I think that, well, I think that there is a question about, yeah, but I think you have already responded. The portion of the decontamination waste that has been collected at the interim storage facility, and how long will it take to collect all the materials at this facility? Do you have a plan for that?
So I think he said in the next year, they plan to have the remainder of the waste collected at the ISF.
Yeah, maybe I can ask a personal question about the plans you have for constructing the disposal facility. Are there any pre-selected, let's say, locations for that? Please.
Yeah, Thank you for your question. So the location is very difficult to task. So, but interim storage facility is located in Okuma City and Futaba City. So, Okuma City and Futaba City understand our action. Yeah, so we can transfer the waste to the interim storage facility now.
Okay, thank you. Mark, do you have any other question for Mr. Momose?
No, thank you very much for your presentation.
Yeah, thank you, Yoshinori.
Yeah, thank
And
you very.
yeah, I hope that we can also count on you for the final discussion if you can keep connected with us. Otherwise, okay, we will manage. Thank you so much. Then
Yeah, thank you so
let's
much.
move to. Thank you again. Let's move to our next speaker, who is Sandon Lee. Mr. Lee is the Principal Associate National Program Director for Homeland Security Research Program at EPA's Office of Research and Development. He has more than 17 years of experience working for the EPA. He has supported the Japanese government in the off-site remediation efforts. Now we have the privilege to listen to Mr. Lee, who will deliver a speech about 10 years of remediation efforts in Japan. Mr. Lee, the floor is with you. Thank you in advance.
Okay, thank you very much. Just want to confirm whether you guys can see my presentation.
Yes, we can.
Yeah, thank you very much. Hi, everyone. My name is Sangdon Lee. I work for the U.S. Environmental Protection Agency. Today, I'm going to present the observations on Ministry of the Environment's environmental remediation and what kinds of lessons that are potentially useful in preparation of similar incidents in the future. So let's see. So this is just formal process. I would like to acknowledge that this presentation is prepared for with the observations from my participation in the U.S. Embassy Science Fellow and also IAEA and MOE expert meetings on environmental remediation for offsite. So this is the outline. This presentation will cover the overview of Japan's environmental remediation, followed by lessons learned and a few key messages for responders and decision makers. The previous two presenters already presented many of the information, much of the information that I was planning to present in this slide. So I'm going to skip those slides. So I'm going to skip this. It is already presented from the previous two presenters. And okay, so it is important which agencies do what in terms of remediation. So this table here, I summarize the roles of major players in the environmental remediation. So I would like to note also that there are other parties such as other prefectural and local governments, academia, industry, but not discussed in this slide. So this table is organized by special decontamination area, also called SDA, and intensive contamination survey area, ICSA, for 4 key players, which their roles are slightly different. So TEPCO is the responsible party for any payment for remediation and provides any support for remediation work as requested. Central government provides regulation, policy, and funding, prepares remediation plan and implements the plan, including worker training and information distribution, specifically in special decontamination area. And for ICSA, central government provides funding, reviews, and approves remediation plans, and also provides technical supports to prefectural government. For SDA, Fukushima Prefecture works in cooperation with the national policy as a liaison between central government and municipalities, mainly conducts information distribution working with the central government. And in ICSA, prefectural government manage the fund for remediation, technical supports to municipalities, such as information and experts, and also they clean up the prefecture facility. For municipal government, in SDA, they help MOE for direct communication with the evacuees and also supports MOE for remediation plan and implementation, such as like landowner identification and coordination of meetings with the evacuees, remediation information distribution to evacuees and coordinate lifting of evacuation orders and coming up with a remediation verification committee meetings. In ICSA, they plan and implement remediation and information distribution. So a little bit more detail, how did Japan prepare the remediation methods? It is important to use the right methods for effective remediation. Japan's central and local governments in collaboration with expert institutes took several steps to identify the most applicable remediation methods, such as shown in this diagram. The methods were selected initially by considering the contamination status and Japan's specific living and natural environment, including like media and surface types. Based on the review information and testbed results, MOE developed the decontamination guidelines in 2011 to support municipal governments for remediation in ICSA, as well as the SDA for remediation contractors. For wide area remediation, Japan's construction companies normally working for public projects like road and dam constructions, they were hired as the main remediation operators. This is because most of the remediation activities are similar to those in ordinary public projects. They are working with the heavy equipment and large number of workers. So MOE used the existing public project framework and added radiation work specific items such as like radioactive material handling, remediation work, worker safety, radiation training, and radiation monitoring program. So let me briefly explain how the remediation is implemented. In SDA, Japan conducted a series of remediation steps, starting with preliminary work, including such as decontamination model projects, preliminary remediation activities, and then implemented the findings to the whole area remediation and also follow-up remediation. The whole area remediation in SDA started with the areas that had lower radiation dose to help evacuees to return to their hometown, as many and also as soon as possible. After the whole area remediation, follow-up remediation, mostly targeting hotspots, was conducted to reduce the radiation level further. So in ICSA, the municipal authority developed a remediation plan, and MOE reviewed their plan for technical feasibility and effectiveness prior to funding. And the remediation was implemented according to the approved plans. Remediation was conducted by single decision units such as someone's house, someone's farmland, school, etc. The figure in left shows decontamination workflows at each site. The individual sites were remediated by following the 6 steps: landowner identification, radiation survey, decontamination planning, and having consent from the landowner, implementation of the decontamination plan, and then post-decontamination survey and monitoring. Thorough stakeholder engagements were conducted throughout the planning and implementation. Within this session, I think the most, the importance of transparent and inclusive engagement process will be, I think it will be further addressed in the later presentation by Ms. Rokyo Ando. Remediation methods were selected and applied based on the following principles. The remediation work was conducted from top to bottom, high location to low location, or from upstream to downstream. This is because to prevent any potential recontamination to remediated or clean areas. During site characterization, hotspots were first identified and then focused for remediation. The hotspots were often found on the rain flow pathways, such as street drains, rain downspout, gutter, drainage points on the eaves, tree bases, etc. Remediation methods were preferred with low waste volume generation. And when remediation waste were generated, incineration waste was separated from other waste types to minimize the waste volume from remediation activity. Remediation methods using water were avoided if alternate methods were available. This is to, again, to prevent any potential contamination spread and to reduce radioactive wastewater. Less material removal methods were first tried, and when the radiation reduction was not effective, then more material removal approaches were applied. For example, the roadway remediation can be tested from less intrusive to more intrusive methods as following order. Removal of deposits, wiping, brushing, not effective, then moving to pressure washing, and even further removal and replacing the entire road surface. Remediation methods with more surface material removal generally provides higher radioactive material reduction. However, these kind of methods also generate more waste amount and it will increase cost and time. The Ozawa-san and Momose-san's presentations before me, those two presentations already show the most up-to-date information on the results. The one thing to emphasize is that MOE in 2018 estimated the impact of the remediation on the air dose rates. And the estimation showed that remediation in special decontamination area reduced approximately 59% more air dose rate compared to the air dose rate without remediation, which means just decaying and weathering. It's the same results that you already saw from the two previous presentations. Similar to SDA, in ICSA, I would like to point out that the estimated air dose rate reduction from remediation in Fukushima Prefecture ICSA was approximately 38% more compared to the air dose rate estimated without remediation. So MOE developed a basic policy for a follow-up remediation, or also known as supplementary remediation, to address what to do where radiation level has not reduced to the target level after the full or whole area remediation. So in SDA, the supplementary remediation was conducted if the air dose rate doesn't decrease below the evacuation level, which is 20 millisievert per year or 2 rem per year. More than 10,000 residences have been the cases for the follow-up remediation. The supplementary remediation has been mostly conducted in water pathways, usually the hotspots, such as slopes, rain puddles, gutters. Around 50% of the air dose rate reduction was actually observed from this supplementary remediation. After the follow-up remediation, continuous monitoring was conducted until the designation is lifted. In SDA, a committee with third-party experts are used to verify the remediation effectiveness. This committee is established in each municipality, consisting of like experts, municipality staff, university professors, etc. The verification by committee is one of the requirements to lift evacuation orders by the central government. The committee investigates the current situation of dose reduction in consideration of future prospects. Committees discuss community recovery for returnees' basic needs, including like housing, medical care, schools, convenience stores, drinking water, wastewater, other utilities such as electricity and transportation infrastructure. The committee residents, the committee activities also include conveying the situation to residents and also collecting input of experts on the topics necessary for lifting the evacuation orders and community recovery. Here is the results of the whole area remediation project based on 2017 and 18 information. So this, trying to give you the size of the decontamination or remediation projects. The sizes of remediation required area about 1,150 square kilometers with 11 municipalities. That is about 450 square miles. This is for the special decontamination area. And then 24,000 square kilometers, which is more than 9,000 square miles with more than 100 municipalities for intensive contamination survey area, which is not evacuated initially. The affected populations are about 80,000 in SDA and about 6.9 million people in ICSA. The total remediation costs were 1.5 trillion Japanese yen, which is about 14 billion US dollars in SDA, and also about 13 billion US dollars in ICSA. This is as of FY 2018. Decontamination waste volume generated in SDA was approximately 9 million cubic meter and 8 million cubic meter in SDA and also ICSA respectively. However, in the previous presentation, most up to date, the waste volume is about 14 million cubic meter from Mr. Yoshinori's presentation. One thing to note is the difficult to return zone, which is also called DRZ. This zone is still in progress of environmental remediation. So it is important to note, how remediation project influences the community beyond the actual technical aspects, in addition to the radiation reduction. So the first thing is anxiety. It is obvious that remediation influences the post-disaster community recovery in public health, safety, social, cultural, and economic perspectives. A study by Murakami and his colleagues investigated the effects of radiation-related countermeasures for anxiety and well-being among residents of one of the town in Miyagi Prefecture. The study results suggested that remediation helped reduce the anxiety of residents after the accident and further contributed to an increase in residents' subjective well-being. The same group in other studies emphasized that the outcomes of remediation is the increase of trust and compliance to local and national government. And as a result, there can be significant improvements in the effectiveness and acceptability of long-term radiation risk management. Remediation project requires significant logistical challenges, including labor, equipment, supplies, and associated needs for workers, such as food, lodging, and health and safety cares. These high resource needs have been positively impacting the economy of the local community. So local, prefectural, and central governments have promoted hiring of local workers, including residents, construction workers, and farmers. This effort included supplies, lodging, and equipment from local community. So these efforts promoted the local resources for remediation project and ultimately contributed to the economic growth in the affected area. Environmental remediation generated large volume of radioactive waste. The generated remediation waste has been stored within the community due to the unavailability of the disposal site. So the residents raised concerns over the remediation waste within their communities, and in some communities, such as Tate City, the incinerable waste caused some noxious smell from the decomposition of waste due to the delayed schedule of the waste transportation to the interim storage facility. So the city constructed the temporary incinerator to process the incinerable waste. this is the lessons learned based on my observation. Japan faced many challenges. These challenges and resolutions from Japanese governments will be helpful for other countries, including US, to prepare for the similar types of incidents. The first thing is holistic preparation of remediation. It is important to plan the overall response in a holistic manner by considering how the results of individual actions would impact the final status of the response. Japanese remediation and waste management challenges demonstrate the importance of this holistic planning of response, especially the need of waste management plan as early as possible. Second one is coordination. Coordination of all relevant parties. It is important to improve the remediation effectiveness and to incorporate future development of community after remediation. So for SDA, where mostly evacuated, the environmental remediation needs close coordination between central government and local government to conduct effective remediation and the community recovery. During the initial remediation efforts in SDA, there were no critical infrastructures available, such as like water, sewage system, waste management facilities, etc. So MOE's coordination with neighboring municipal governments was critical to get access to those resources and facilities for timely remediation. The third one is the selection of remediation methods. As observed from Japan's environmental remediation efforts, there is no single method that can work for all surfaces and media. So when wide area is contaminated, many different remediation methods are needed because of various types of surfaces in the contamination zone. So the remediation methods needs to be tested against the actual contamination conditions, because these methods may not be as efficient as they have been documented or previously tested. Roles of experts. In Japan, radiation experts help the decision makers, such as mayors or of local governments, to identify and implement the remediation technologies and also to interpret the results. They help the government officials to communicate with the stakeholders and the general public. So timely delivery of expert opinion to decision makers and stakeholders is critical to respond to and recover from the disasters. Stakeholder engagement for remediation. Clear and transparent communication with stakeholders helps improve the public trust, and as a result, improve effective decision-making during the remediation and community recovery. Remediation workers and work environment. Wide area environmental remediation is labor-intensive. In Japan, the full-scale remediation or whole area remediation required large number of workers, nearly 80,000, for more than 5 years. It is challenging to supply this large number of workers for extended period of time. So hiring from local community was promoted in coordination with the local communities. And this coordination was the key to resolve the most challenges, such as hiring and procurement of supplies, including foods and the remediation equipment. The next item is the hotspot identification. In Japan's remediation, seasonal hotspot removal was the most effective approach to reduce the radiation level with minimal efforts. Importance of availability of critical infrastructures. This has been previously also mentioned, that environmental remediation should focus on the critical infrastructure structures, such as transportation structure, utilities, medical facilities. When these critical infrastructures are closed or restricted for operation because of contamination, then the community wider than actually the contaminated area will be impacted. So the critical infrastructure remediation is set as a high priority. Impact of environmental conditions on remediation implementation. Application and effectiveness of remediation methods were greatly impacted by the extreme weather conditions, such as extremely cold and hot weather, sometimes typhoon, sometimes monsoon season. The remediation plan should consider the potential impact from these kind of extreme weather events. The last one is the remediation of the natural area. In Japan, large natural areas such as forest and aquatic area has been contaminated, and it is still challenging to remediate these areas effectively. Remediation will take enormous amount of time and efforts. In addition, remediation may cause significant side effects such as erosion can occur after usual remediation efforts. So Japan focused on the remediation of natural area near the inhabited areas first and continuously assess the potential impacts to those areas. So the question is, if these contaminated areas are still left to be contaminated for a really long time, we are talking about like decades, then what would be the consequence from severe extreme natural disasters related from like climate changes, including wildfires and like tornadoes and like hurricanes. This is my last slide. So the scale of contamination was unprecedented in Japan, and Japan's efforts to remediate the impacted areas showed us many valuable lessons. Here are some action items. I think it will help our preparation. Radiation experts, the experts in radiation protection should be readily available during the instant response to help decision makers and public to make informed decisions based on the most current and scientific information. So the radiation experts need to be continuously educated and trained in preparation of a wide area radioactive contamination event. Remediation technologies. Many remediation methods have been applied and reported for their effectiveness from previous contamination events and sites. It is evident that there is no single technology or method that can remediate all different surface and media types as seen in Japan's efforts. It is recommended that the government authorities develop capabilities to readily implement the remediation methods as needed. This will require identification of which remediation methods are suitable for their specific surfaces and media of concern, and the responders should get trained how to implement those methods. The third one is the labor and equipment. Wide area environmental remediation requires enormous amount of labor and equipment as observed in Japan's case. The authorities need to identify in advance how the remediation workers will be trained quickly and supplied to the actual remediation sites, and how the equipment for remediation will be supplied. The trainers and training programs should be readily available. Holistic preparation. Environmental remediation is composed of series of activities, and each activity has impact to the following activities, especially waste management. The responsible party needs to prepare the wide area remediation for seamless operation. There are various types of decision support tools available, which can help government authorities to assess their remediation operation and which steps need further improvement. The last, the message that I would like to convey is the exercises. Most nuclear power plant accident exercises are focused on the emergency response phase. The exercises need to be extended for long-term whole area environmental remediation. As observed in Japan, the wide area remediation may impact the community in all aspects, including public health, economy, culture, etc. So these exercises should include discussion on not only the technical aspects of remediation, but also on the social aspect for community recovery overall. That's all I have, and here is my contact information. Thank you for listening.
Hi. Thank you so much, Mr. Lee, for your very, very comprehensive and interesting presentation. I don't think we have any specific question for you from the audience, but if you allow me, I would like to ask you a couple of questions. Once again, you mentioned the need for a strong coordination about the different actors related to the remediation. In some of your slides, you put together the role of the different actors, including TEPCO, government, prefecture, and municipalities. May I ask you for a little bit more if you could elaborate a little bit more the role of TEPCO and how population perceive this role in, let's say, helping the situation? Are they perceived kind of as the problem makers, or now the ones that could help in finding the solution for this problem? Up to what extent this perception from the society around Fukushima, please?
Thanks for question. That was also my question when I was actually supporting the Japan's remediation work. I have some private conversation with the Japanese people. However, I don't think that can represent actually what is the public's perception about TEPCO. What I can tell you is, based on my observation, TEPCO has been developing monitoring system or monitoring devices, also the program, and also they've been providing some remediation support as needed, like if any municipalities or prefectural government is asking, okay, this is our difficulty is TEPCO, can you help us to fix this problem? So TEPCO is doing also the main part is when MOE finishes the work and regularly they are sending the bill to the TEPCO, and TEPCO is corresponding to the bill. I do not know how much they are paying up to date. However, that's the process that I know. In terms of the perception, TEPCO is the responsible party. Public knows that TEPCO made the mistake. And then as a result of mistake, this kind of contamination events happened. So what is TEPCO's participation in their recovery process? And then what is the public's opinion? As far as I can, it is more than just as it seems to be. It has more complicated relationships, such as TEPCO's shares actually purchased by the government, and also some inside there are more than complicated situations that I can understand from outside. So with those information that I don't have, I cannot tell you what is the actual relationship. But I think on the legal standpoint, the TEPCO is the responsible party that I know. And then TEPCO has to pay for all the payment for the remediation. That's all I can tell you. I don't have much of the information on the perception.
Okay, thank you. That's very clear. I have some other questions, but maybe we can address them as part of the final discussion. I don't know, because I think your presentation was very clear, and maybe this can trigger some discussion about I can advance issues such as self-remediation, etc. But I don't know, I would like to move to Mark. I don't know if you have any question, Mark, or you can introduce our next speaker, please.
Yes, so Sang-Don, thank you for the presentation. One question I have, I was very interested in the last couple of slides where you talked about the knowledge management and remediation technology effectiveness. So are there any efforts by the international community or within the US to systematically capture the experience and effectiveness? It seems like that would be very, very beneficial information to have readily available to folks in the future.
Yeah, thanks for the question. I think from international community standpoint, I think Horst can answer better with the IAEA's efforts. I think that's the most significant effort. Within the United States, within especially U.S. Environmental Protection Agency. We are collecting those information and combining with our efforts that we have been collecting and testing. It is not in the level of systematic way. However, we started collecting those information and trying to figure out whether they can be applicable in our current situation with some Superfund site cleanup and others. Well, maybe I'm going to ask Horst whether you want to talk about IAEA's efforts on this.
Yes, no, I think that Horst, I don't know if we can unmute Horst.
I can.
Or maybe, you can. Okay, then Horst will
mute yourself. Mute yourself. Yeah. Can you hear me? Maybe there is a kind of interference here. I come to that, Mark, when in my presentation. Okay.
Very good. We can do that at that point. Juan Carlos, are there any more questions for Sang-Don?
no, from my side now. I would insist that I would prefer to keep some questions for promoting the final discussion, so that I will go back to you, Mark, for the next speaker, please.
Okay. Kieran, I know we had talked about possibly moving forward with Ryoko Ando's presentation, but should we go ahead with the break now?
I think we should. We've nearly caught up with our schedule. So let's take our break until 7:35.
Okay.
As scheduled. Thank you.
Okay, that's fine with me. Thank you.
Thank you.
Good.
following our break. Thank you.
Our next speaker is also from Japan. She is Miss Ryoko Ando, and she brings a very unique and valuable perspective to remediation of the Fukushima area. In 2011, she formed an organization called Ethos in Fukushima, and that organization has engaged citizens in some of the small communities to understand radiation exposure, and radiation protection, as these were all very foreign and abstract concepts for people. She's also worked with the International Commission on Radiation Protection to coordinate a series of dialogue meetings with local citizens. The intent of those has been to build trust between the public and scientific and remediation experts. And subsequent to that series of meetings, she has continued the dialogue format that was started there. And so now may we have Ms. Ando's presentation.
Effective risk communication and public engagement approaches. The case of the decontamination process in Fukushima. Hello everyone, my name is Ryoko Ando from NPO Fukushima Dialogue. I will start today's presentation by introducing myself. I was born and raised in Hiroshima. I went to Tsukuba University in Ibaraki Prefecture and studied comparative culture. I started to live in Fukushima in 2003 when I married my husband who is from Minamisoma, Fukushima. Before the Fukushima accident, I was not interested at all in nuclear energy and radiation protection. It's only after the accident that my experience in radiation risk communication began. I have been involved in two main activities since the Fukushima accident. The first is to participate in the ICRP's dialogue, bringing together stakeholders from inside and outside of Fukushima. It had been held 22 times so far. In 2020, ICRP's official involvement ended, and now the NPO Fukushima Dialogue, of which I am the president, is running the event. The other is the radiation measurement activities in the small community of Suetsugi, Iwaki City, Fukushima Prefecture, where, together with local residents, I worked for 9 years from 2012 to 2020 to help them recover their lives. We have written articles about both experiences. If you are interested, please have a look. Today, the previous Japanese presenter gave a presentation on decontamination. I would like to speak from the perspective of what decontamination has been like for the residents. Through my work with Dialogue and in the Suetsugi area, I have had the opportunity to hear many stories about decontamination because it was a serious concern for the residents of the affected areas in Fukushima Prefecture after the accident. Before we talk about decontamination, allow me to give you some background on the resident situations after the accident. First of all, very few people had any knowledge of radiation. If they did, their knowledge was very fragmentary. The amount of knowledge and the sense of risk varied greatly from person to person. There was hardly a common understanding of radiation that people could share. There was also a lot of resentment and distrust of the Japanese government and TEPCO for what had happened. For years, the Japanese government and TEPCO kept explaining that an accident could not occur. There was also a strong distrust of the scientists and experts who had developed and supported nuclear technology. For the residents, their lives were severely disrupted by the accident they never expected. Although it was not their choice, they have been changed their way of life. As a result, there was a very strong feeling among the residents that things were going back as they were before the accident. We want things to go back as they were before the accident. I have heard these words very often. This is where decontamination came in. The fact is that most people know as little about decontamination as they do about radioactivity. They didn't know what it was, but they were under the impression that the decontamination was the definitive solution to get rid of radiation and get life back as they were before the accident. Look at the picture. The beads represent radioactive material, and the objective is to collect them and store them in boxes. This is how the person in charge of decontamination in that city explained to residents what was going to be done because they did not understand what the decontamination was for. It should be noted that it was exceptional for the authorities to give such a clear explanation. Please see the next picture. This is a briefing in 2012 in the Suretsugi district of Iwaki City. Mayor sitting in front are representatives of the authorities. It was a one-way briefing, with a document prepared in advance being distributed and read out loud. A resident asked, "To what extent can you reduce radiation by decontamination?" He was told that the government of Japan set in the standard of 0.23 microsievert per hour for deciding areas to be decontaminated. However, due to complete lack of understanding of radiation, 0.23 was perceived by the resident to be a safe standard for radiation. The resident asked authorities to promise that decontamination would bring the level down to 0.23 or lower. In fact, at that time, the government officials were also confused. On the one hand, some of them didn't understand what the 0.23 standard meant. On the other hand, others promised the residents that they would lower the level of contamination below 0.23. This is how the 0.23 value became a border between safety and danger for the residents and also a promise from the administration. Now the decontamination process has begun. In this process, the residents have come to know what the decontamination was concretely, like cutting down trees, stripping the soil, washing the walls, and so on. A private construction company undertook the decontamination work. In areas where people live, a person in charge explained the work results to the residents. Having the situation explained directly meant a lot to some of the residents. They were able to understand the situation better and felt that they had been treated appropriately. On the other hand, some of those who had not benefited from the decontamination as expected were not happy. Since it was a public project, the authorities said that the response had to be the same for everyone. Therefore, it was common for the authorities to reject the residents' suggestions for more effective and rational decontamination. This led to a strong sense of frustration among the residents, who felt that the authorities did not take appropriate action. Several years after the decontamination was finished, I asked some residents what they thought of the decontamination. Many people were satisfied with the fact that the decontamination had reduced radiation levels. They were also happy that the decontamination had been carried out. But on the other hand, they were very dissatisfied with the process. Many of them strongly complained that their opinions were not listened to at all. They also complained that the authorities sometimes could not get the level down to 0.23 as promised. When I asked them if their trust in the authorities had increased, they said that it had not increased at all. Several years after the accident, most residents knew that 0.23 was by no means an indicator of safety and danger, but nevertheless, residents were satisfied with the decontamination work. Despite these facts, the residents had even less confidence in the administration. The main reason for this was that their opinions were not listened to in the decision-making process. Thus, the issue had become one of the decision-making processes, and not just of risk. There are still areas in Fukushima Prefecture where the evacuation order is not expected to be lifted in the near future. These areas have not yet been decontaminated. In areas with high radiation doses, decontamination may not bring down radiation levels sufficiently. The Japanese government said that budgetary constraints make further decontamination difficult. Residents in these areas are calling for decontamination. They say, "We've been waiting for 10 years. Why can't you just do it for us? And you have polluted our property, so it is only right that you should clean it up and return it to us." This means that in addition to risk and decision-making process, the ethical issues of fairness, equity, and responsibility have become serious problems. There is a strong sense of unfairness in the evacuation areas that have not been decontaminated. Now the residents of the evacuation zone are insistently demanding decontamination. It has become an ethical issue in our society, which is far removed from the original goal of decontamination, which was to reduce the risk. After finishing the decontamination work, there was another big problem. It is the issue of waste. The waste has been taken to an intermediate storage facility built in the evacuation zone around the nuclear power plant. The law requires that this waste to be transported out of Fukushima Prefecture after 30 years. However, there is no decided final destination for the waste. Everyone in the affected areas knows this, and few believe the government's promise will be kept. Now, let's take a look back at the 10 years of decontamination work. First, a risk event occurred. So the first question was about risk. Is it safe or dangerous? That was the main focus. Decontamination was carried out to reduce the risk. Then a new problem was added in the decontamination process: the administrative response to the decision-making process. The dissatisfaction and distrust of the administration that arose from these problems have remained over time. As the decontamination work progressed, the inevitable problem of waste arose. Again, the government made empty promises. Many people believe that a government that has never listened to them and only made decisions unilaterally will not keep its promises in the future. What started out as a matter of risk has, over time, become a matter of grievance against the authorities, and now it's an ethical question. Each new problem became more complex as it arose, mixed with previous ones. If it's only a risk problem, we can deal with it by reducing the risk. If it's only a question of procedure, we can improve the situation by improving the procedure. But ethical issues are a different matter. When it comes to an ethical confrontation, it is because the stakeholders have generally experienced emotional conflicts before. Emotional conflicts have a profound effect on our minds and remain firmly in our memories. Negative emotions such as distrust, resentment, and hopelessness can seriously affect decision-making processes. It's difficult for anyone to resolve in a short time ethical confrontations caused by emotional conflicts related to a situation that has recently taken place or is in the process of being unfolded. This is why it is desirable to take ethical aspects into account from the outset in order to avoid problems later. Considering the ethical dimensions upstream makes it possible to deal with other problems such as reducing risk or improving procedures without unnecessary frictions. How to communicate effectively on risks? In the case of Fukushima, the situation got complex as time passed. One of these reasons is that we lacked the views of the ethical aspect. If we had taken care of the ethical aspect from the beginning of the process, the current situation would be much better. From our experience, we can state that one of the most important things in situations like a post-nuclear accident situation is to build trust. If you don't have trust, then even if you achieve your initial goal, as in the case of the decontamination process in Japan, you will face one problem after another, and gradually you will be in front of a bigger problem with no solution. But the next question is, how do we build trust? It is essential to include stakeholders in the decision-making process from the very beginning. If the authorities decide unilaterally, they may let some time pass, but inevitably this will result in a strong and deep-rooted sense of mistrust. What matters is to give a clear picture of the real situation. It is vital to have ongoing discussions with stakeholders to distinguish, as far as possible, between what is a risk issue, what is an administrative procedural issue, and what is an ethical issue. It is also essential to have a time horizon of the following steps and what the future holds. No one can trust a plan or action if they don't know what the future holds. There is no only definitive solution to respond to a risk event. Things can sometimes go wrong. When there are mistakes, the ability of people to accept the consequences depends on the reliability of the process. That's why it's so important that the process is transparent and fair. Now, finally, let me advertise our activity. We are organizing a meeting to discuss the Alps treated water at Fukushima Daiichi that TEPCO will release into the sea on the 28th of November. Simultaneous interpretation will be provided, and we will stream the event via Zoom. A recording will be available later on the website. This is an excellent opportunity to see what the issues are at Fukushima at the moment. We look forward to seeing you there. Thank you.
Karen, one observation I would make on the presentation here is this is a very good case study for all three of our panel discussions that we have scheduled this week. The one today on community revitalization is really fundamental to the overall recovery efforts in Fukushima. And also We just heard about stakeholder engagement and the different ways in which that needs to proceed, and having good procedures or processes in place that really understand how to communicate with folks. And the ethical considerations that Ryoko discussed are really front and center in the environmental justice discussion, which will be, I think is tomorrow. Is that right, that panel?
That's correct. So we really have a perfect queue up, and I appreciate you drawing those lines to those panel discussions, Mark. Definitely a cross-cutting set of issues.
Right. So we ready for the next speaker?
Mark, I assume you will introduce our next speaker.
Yes, so our next speaker is Horst Monken Fernandez. He is with International Atomic Energy Agency's Decommissioning Environmental Remediation Section. He's led several missions to Japan, several IAEA missions to Japan that looked at reviews of the remediation processes taking place there. So he has been a long-term advisor to the Japanese and is also working to incorporate lessons learned into IAEA practices. So Horst, I'll turn this over to you.
Thank you very much, Mark. Can you see my slides and hear me?
Yes.
All right. So Karen, Nick, colleagues, thanks for the opportunity to speak about remediation efforts in Fukushima in this event, and congratulations for organizing RemPlex. Really sorry this could not happen in a face-to-face capacity. As much as we have learned to take advantage of the virtual world, personal contact and exchange is really unreplaceable. I have a problem here with my computer. Okay, so this is pretty much the outline of my presentation. Let me start by saying that one thing that is very important when we talk about an issue is that we need to be on the same page. That means have the same understanding about the meaning of terms and concepts we are talking about. This is why I start with definitions adopted by the international community as reflected in the IAEA Safety Glossary. From that point, I intend to revisit the framework in which remediation is supposed to be implemented, and from there, examine the scientific basis for the implementation of environmental remediation related activities. In the sequence, I would like to share the findings of two pioneering missions implemented by the IAEA in 2011 and 2013 in Japan, which I have the honor to coordinate. By the way, Juan Carlos was the leader of those missions, and talk about inputs coming from the research community using the Territories project as an example. I like to flag recommendations by the IAEA-led Conference on Decommissioning and Environmental Remediation implemented in 2016, and finally present what the IAEA is doing to contribute to address the raised topics in these sessions, with particular focus on decision-making in the scope of remediation, emphasizing post-accident situations. By the way it was organized, it flows very nicely into my presentation. Still have problems with moving the slides. It's frozen for some. Okay, so this is the IAEA Safety Glossary that defines and also explains technical terms used in safety standards and other safety and security related IAEA publications. It also provides information on their usage. So harmonization in the use of understanding of terms are very important things because it helps to avoid conveying contradictory messages, but more importantly, raising unrealistic or unjustified expectation with a consequence creation of confusion among the stakeholders. And I will talk about it. So let's get started. To begin with, remediation that we talk too much about it can be understood as any measures to reduce the radiation exposures due to existing contamination of land areas through actions applied to the contamination itself, the source, or to the exposure pathways to humans. I firmly believe that in the case of Japan, the use of the concept, the term of decontamination, as has been extensively discussed during this presentation, caused a lot of problems, as it might have indicated that the aim of the work was the removal, eventually the complete removal of the contamination, something that is not implied by remediation. That has to be made very clear. It is also common to see the use of terms such as rehabilitation or restoration to convey the same meaning of remediation. The problem here is that such terms may be taken to imply that the conditions that prevail before the contamination can be achieved again, and unconditional use of the land areas can be restored, which is not usually the case. Cleanup sometimes is also referred to, but the term is to be used in the context of decommissioning, but that is differently conversation. Now, we also deal with the terms of contamination, and that is automatically the problem with the term is that it automatically leads people to the understanding, or better to say, to perceive that once something is contaminated, it becomes automatically dangerous. In this respect, it can be expected that if something is said to be contaminated, the needed counteraction is to decontaminate. But decontamination might not be the optimal solution in the scope of remediation works. We can see that in some situations, great efforts will be paid to decontaminate surfaces and media, that at the end of the day, these efforts will not have major impact in reducing doses to people. That's what is important. As we will see later on the main messages, one of the main messages given by the IAEA organized missions to Japan was in the direction of the need to speak about doses. Let's emphasize that. We need to speak about doses and not becquerels per grams or becquerels per square meter. Indeed, you can reduce doses without decontaminating a media, and even more important, without generating significant amounts of wastes, which has been commented here by my predecessors um, in these discussions. Now, I thought about the framework. The IAEA Safety Standards GSR Part 3, also called the BSS, established the basis in which remediation is to be implemented. It is a non-binding document, but yet a consensus document. And by that, I want to say that IAEA member states and other international organizations endorse the idea, concepts, and recommendations embodied in that and other similar publications. The framework for remediation established that remediation is to be seen in the context of an existing exposure situation. This is very important. That means remediation is typically associated with environmental interventions in the so-called legacy sites and areas affected by a nuclear or a radiological accident. Remediation of the natural environment, let's be clear about it, is also possible. By existing exposure situation, it means that one does not plan to have an accident, but instead, once an accident happens, you'd better have in place plans to deal with the consequence of the accident. Likewise, you do not plan to run an operation in such a way that you will leave behind a situation that can cause harm to people by means, for example, of the improper management of waste. On the contrary, you plan for an operation to be implemented in the safest way possible. Exposures associated with planned activities are characterized as planned exposure situations. Note that in the case of existing exposure situations, once the remediation is justified, a reference level between 1 and 20 millisievert is to be adopted. We will understand these ideas a little bit better in the next slide. So here we can see those limits and those constraints. And these are adopted in planned exposure situations. The planned activity needs still to be justified, and the resulting doses that shall not exceed the value of 1 millisievert shall be optimized to ALARA. What does it mean? as low as reasonable achievable. In the case of exposure situations, as existing exposure situations, I want to say, the upper boundary uh, of reference levels is 20 millisieverts per year, and effort should be put in place to reduce the residual dose to what could be considered an optimized level that does not necessarily be equal to 1 millisievert per year. And this is something that we generally see happening in remediation efforts, to adopt value of 1 millisievert per year as a target for remediation efforts. And that is very confusing. At this point, it is very important to understand the scientific basics that support radiation protection. I do like this slide from Mr. Abel Gonzalez. Mr. Gonzalez was a former director in the IAEA, but also a member of the ICRP and the UNSCEAR. You will see that in the relationship between dose and effects, this region can be divided into three subregions. At the higher doses region, the effects of radiations are clinically observed. A second region is one where effects can only be statistically attributed by means of epidemiological studies with populational groups when they are implemented. Finally, there is a region where effects are inferred as they can be considered biologically plausible. The only way that we can be assured that no effect will be observed would be in a zero dose situation, which is not found even in natural environments because we are all exposed to natural radiation. And this is indeed where most situations where we are dealing with remediation will fall. So where are we now? So at the moment, we spoke about different concepts and different terms, all of them with a specific meaning. Uh, and in many more situations, more terms are needed. We will talk about those. External dose. We'll talk about internal dose, risk, reference level, dose limit, stochastic effect, probabilistic effect, if you wish, deterministic effect, karma, contamination, remediation, decontamination, radioactive waste. We will speak about cesium-137, cesium-134, iodine-131, deposition, site characterization, evacuation, zoning, and then organizations like ICRP will be mentioned, IAEA, UNSCEAR, expert. We will not speak about milligrams per kilograms. We will speak about millisievert per year, becquerels per gram, as my predecessor just mentioned. All these terms completely not known by uh, members of the public, of lay people. And all these terms, they have a kind of very clear meaning. So not only we need to be able to communicate all these concepts to a wide range of stakeholders, but most importantly, we will need to make decisions based on mutual understanding of each one of them, if possible, with a regional level of a consensus. And then my question is, this is something like mission impossible. So this is one of the things that I wanted to emphasize. So the key issue then is to establish the role of science, which is the objective of my talk, in the complex decision-making process. It's not only about communicating, and involving stakeholders. One cannot expect that lay people have the same understanding of scientists and technical professionals on which one of the concepts I just mentioned before. Let alone there is also divergence among the so-called experts. The questions to be addressed are: does science drive the process or does it inform the process? Note that the ALARA concept clearly states as low as reasonable achievable, but it's also complemented, and many people forget about that, by social and economical aspects being taken into account. This is an explicit recognition that the definition of, for example, reference levels under a process of justification, optimization, is not only a technical scientific process, but incorporates subjective inputs and preferences. Big problem is that certain demands that will come from the community, for example, will come with a price tag, and the price tag can be very high. So let's take a look now on what has been said by the two IAEA review missions implemented in the aftermath of the accident in Fukushima. In the first mission report issued in 2011, and by the way, they are available in the IAEA webpage, we talk about net benefit. We also talk about avoiding over-conservatism that would not contribute to meaningful reduction of doses incurred by members of the public. Another point was the message that radioactive waste was being generated. In fact, we should have talked about materials with some levels of radioactivity in it, not necessarily radioactive waste. But more important than anything was to focus the decisions not on activity concentrations, but on doses. And that was the concept with the proper messaging of the, that was a problem with the, connected with the proper messaging of the concept of decontamination and contamination. And of course, at the end of the day, remediation. In other words, more than reducing the contamination, remediation should be seen as reducing the doses. I will repeat that again. Unfortunately, to my understanding, and I'm not representing the IEA on this is my personal opinion, these ideas were mishandled, and one of the results was the generation of huge amounts of waste. And by the way, if my understanding is correct, the term remediation does not exist in the Japanese language and not in some other language. So this is why the term decontamination was applied. In the second mission in 2013, we reinforced that reference level did not need to be 1 millisievert, but any number in the range between 1 and 20 millisievert could be accepted. Yet, optimization was to be implemented, and the 1 millisievert per year could be seen as conceived originally as a long-term goal instead of being achieved right away. Other key thoughts that were also important to discuss were the concepts of life cycle of remediation and what Sang-Dong Lee just mentioned, the holistic view of the process. That is very, very important. That means how things are connected and how decisions are made in the present, but also in how it will impact us in the future. So the waste generation, for example, needed to be integrated in the overall planning. It's not just you have the waste and now we need to find out something that we will do with the waste. No, when you implement a strategy, you need to see what the consequences of that strategy will be, and then you need to discuss this clearly with the involved stakeholders. And this is where science plays a key role. Also, let us not position ourselves in terms of the performance of different methods in terms of removal of contamination, so to speak, but let us see the impact of these efforts in the reduction of the different doses. And so these were messages that were clearly conveyed by the IEA missions in 2011 and in 2013. Territories Project. It's a project developed in the European Union that offer, from the perspective of the research community, important inputs to bring science together in the overall decision-making process. It focuses on uncertainties and variabilities and touch upon these uncertainties on site characterization, mathematical modeling, and also on the understanding of the behavior of radionuclides in the environment. Key recommendations of the territories projects to have been formulated. I will focus only on a few of them that are relevant to the decision making. First, the important step of making clear role and responsibility. Sang-Don mentioned, talked about it. The necessary engagement of stakeholders in transparent dialogue, also touched upon by my predecessor. Speak about waste management challenges, hubs of expertise, also mentioned before. And I would add under proper coordination. These things are very important. But I want to highlight the need to develop a decision supporting tool that can back up choices of remediation strategies that prove to be cost effective, sustainable, and here is the life cycle thinking, but they can also provide for the proper reassurance of the affected communities. The Madrid conference uh, are very well aligned with what the Territories Project came up with. So the Madrid conference was organized in 2016 on the Commission on Environmental Remediation. The conference raised awareness and called attention to the need to have inclusive dialogue with stakeholders on the development of reasonable reference levels, which for post-accident situations would apply in the existing exposure situations after the emergency phase has ended. The conference understood the fear of stigmatization by raising the possibility of accidents could be an issue for a particularly member state. Therefore, it was suggested that international guidance could be issued and recommendations should be developed for all countries to adopt. And this is really where we come in. The bottom line here is that this dialogue that integrates science in complex decision-making process is not trivial. Recapping what has been said so far, the very challenging aspect, in my view, is exactly the limited technical knowledge and understanding of science lead to risk perception based predominantly on emotion and fear. Considering that we will always hear that it's important to establish trust, 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 the magical word. But trust is exactly the first asset that is lost in the aftermath of an accident. So a process must be in place to allow to get things done under these circumstances. To take care of these demands and try to respond to these challenges, the Maestri project has been launched. And the Maestri project stands for Management System Supporting Environmental Remediation Project. Maestri aims to establish a structure framework that considers in an integrated manner the different dimensions and activities relevant to management of sites contaminated by ongoing and past activities, including accidents, with a view to bringing them to sustainable end states suitable for beneficial use. We propose in the scope of Maestri to work not with a narrow concept of remediation, but broaden the approach to a more encompassing view of management. We have the ambition to move from the theoretical formulations to action-based activities that include case studies and practical guidance demonstrating the use of the framework. This slide is just to show where we are, and we will be concluding the baseline report in 2021. I will come back to this. From 2022 on, Maestro will work with 3 working groups that will bring social dimension into the considerations of the decision-making process along with technical and scientific dimensions. But the final aim is to establish the community of practices that can apply and demonstrate the usefulness of the established approach and needs for improvement based on case studies. As a result, reports, training materials are supposed to be developed. The starting point, as I said, was the development of a baseline report that is almost concluded, revisiting and reporting on different decision-making methods, tools, and approaches to be considered in environmental remediation, and making consideration on the options of sustainability in the scope of environmental remediation, as I said, moving to environmental management and pointing out the specific and concrete needs to be addressed. By the way, those of you who attended the opening address by Mrs. Rebecca Tadassi, we'll see that NEA OECD activities in this regard and ours, they are very much aligned to each other. I guess that at this point, as established in the terms of reference of the project, the big step is to keep the good working being done by the scientific and technical community on different techniques, technologies, planning and managerial approaches used in remediation, but integrating the social science community to enhance the outcomes of these efforts in a way to do our work better. As a vision, we could consider, for example, even the use of artificial intelligence, not as a replacement for decision makers, but potentially as a benchmark, a tool to support the project decision. Therefore, I am particularly very interested to see the discussion of artificial intelligence in the scope of RemPlex. It would be great if we could explore some avenues for cooperating between IAEA and PNNL, since a practical arrangement between both organizations is being discussed. So as the final message, yes, making decision is really in complex situation, such as in the aftermath of an accident, is a real challenge. No doubt about it. The community has expressed the interest and need to have guidance on how to address this issue. This is also very clear. I could speak about COVID-19 and make some parallels. For example, how science has been so important to help us to cope with the situation that we are facing now, but at the same time has been challenged in ways that, to me, were quite surprising. But to be honest, this is not quite new to nuclear. This speaks in favor of the so-called holistic approach and integration of competences, and Maestri, as I mentioned, is intended to be a platform to face this challenge. So I would say, please join us in this effort and let's work together. As a final message, thank you very much for your attention. Congratulations again to PNNL to organize this fantastic event, and I will be more than willing to address any question our audience might have. Thank you so very much.
Thank you. Can you hear me, Horst?
Yes, loud and clear.
Okay, thank you. Thank you for your very nice presentation that illustrated very greatly how things are working and how we are trying to progress on this area. But may I ask you something? You mentioned several times issues such as those related to the need of developing additional guidance, maybe additional technologies, etc., for covering the post-accident phase. If I remember well, the Fukushima report that was delivered by the agency covered several areas, including nuclear safety for operating nuclear power plants, emergency response, etc. And one of them was about remediation and decommissioning. May I ask you, what in your view are the elements that make different reaction from the lessons learned that have been identified in this Fukushima report? For example, for nuclear safety, there are a number of regulators developed new systems, new, let's say, supply or etc. systems to enhance operating nuclear safety, while we don't have the same response, maybe for post-accident remediation, etc. Is there something related to a lack of interest of the governments and agencies? Or what, in your view, are the elements behind this lack of sufficient progress in this area? Thank you.
Yeah, thank you, Juan Carlos. That's an excellent question, and I think I addressed maybe very fast in my presentation. When we talk about post-remediation situation, we are assuming that an accident will occur. And by doing that, we heard in Madrid conference, for example, that the problem of stigmatization could take place. I guess that emergency response is a de facto situation. It's a given. So the community recognize that this is an issue. This is something to be done. But when we speak about remediation, so the willingness to go to that direction is really not the same. So I think that what we are trying to do here with this project with Maestri is to move forward and provide the guidance that the community is asking for and is so much in need. You will remember when we were in Japan that we said many times that for a reference level that would be related to a residual contamination, any number between 20 and 1 would be acceptable. It's written in our reports. But the question is, which number do I pick? How do I pick that number? And that is really what we need to provide, the kind of input we need to give. And that can only be done if we bring all these things that I mentioned together in a participatory decision-making process, as my predecessor just mentioned, providing the opportunity for the affected people and other stakeholders to participate in the discussions, but also having the opportunity to demonstrate the consequences of each decision in the short, medium, and long term. Sang Dong talked about ICSA, which was essentially areas where stakeholders have a say in the decontamination strategies to be chosen. The point is, were they really aware of what would be the long-term implications of that? So we need to bring those things together and have the system in that can do a better work than we have been doing so far. That's my position.
Okay, thank you, Horst. I don't know if we have any other question for you. Mark, maybe you have something for Horst before we move to the general discussion, please.
Yes, just a question or clarification. So as I understand it, the Maestri project is focused on environmental remediation generally, but it's also encompasses accident response. So am I understanding that correctly?
Yeah, it is, of course. Yeah, of course. It will definitely deal with existing exposure situations in which remediation after accident is included. So in an existing exposure situations that I demonstrated, we deal with the so-called legacy sites that were generated in the past by proper management, but also deals with a post-accident situation. So the framework we are intending to put together will be useful for these cases.
Okay, thank you. And so I gather then that's one way to reduce the stigma of talking about nuclear accidents or potential for those, while also maintaining the dialogue about the safety of nuclear power.
Well, we need to be sure, we need to make clear that the probability of something occurring is like a nuclear accident is really, really very, very, very small. But that doesn't mean that we should not have mechanisms in place to take action in a better way than we have been doing in case something happens. So I think we should overcome that barrier and be able to communicate this without the fear that this will cause stigmatization by getting people to understand, oh yes, an accident can take place. Maybe if we change the focus of that conversation and say, okay, but if it takes place, we can manage, like we are able to RemPlex and what you guys DOE are doing in dealing with the legacy sites that you are working with, is a strong demonstration that we have the tools, the capabilities, the intelligence, the means to take care of what has been done. So that's the conversation I think we should be having.
Okay, thank you. And Juan Carlos, do you want to transition to the panel discussion now at this time?
Not now. Okay. Yes, I think this is the right time to move to the panel discussion. And I think we have some questions in the chat. It's for maybe Mr. Lee and Momose. Could you please turn on? No, sorry, this is about logistic. It's nothing to do with that, but I can't see any special question. If not, I can ask you, Mr. Lee, from your presentation, we saw that there were some specific projects or pilot projects to test specific methodologies and technologies for remediation and decontamination in particular. And they were managed by workers. My question is about the experts or the workers that are implementing those projects. What could you elaborate a little bit more about training of the workers, and specifically about what are the let's say elements that Japan has put in place to control the exposure of those workers? Are those exposed workers or are just members of the public with a specific training? Could you elaborate a little bit more about that, please?
Hey, Juan, is that to me? The question is to me?
I think that you could share between you and Mr. Momose, okay?
Yeah, I can start with it. I think the Momose-san can actually elaborate further, but I will first discuss, what I have observed. So number one thing that we have to keep in mind is the area is like 24,000 square kilometers, and then the dealing with the decontamination work is like the several million people residents that the decontamination work has to happen. And then there is no the immediate priority, which municipality should be cleaned up first. All the municipalities are starting planning, and as they progress, the remediation plan has been reviewed by MOE, and as soon as it is approved, the decontamination has been implemented. So with that setup, when you look at the remediation project overall from central government, it is happening all over the place. And because of that, you need a lot of actual remediation workers. And then the number of workers keeps growing as the remediation plans have been approved by MOE, and then municipalities start implementing. At the same time, special decontamination area already in progress of remediation. So two areas are happening, but don't forget about actual on-site work, right? So nuclear power plant itself is also in progress of, dealing with the emergency and then also decommissioning process. So when you look at all those things that are happening, as far as I recall, the nuclear power plant itself is taking care of, having at least, 5,000, I heard 7,000 people every day. They're working on site. And then they are all radiation workers, properly trained, they are really high dose level of exposure job. And then now let's look at the SDA. SDA is almost 30,000 and 35,000. That's what I heard 5 years ago, but it might not be true, or maybe some correction. And then the ICSA is also almost the same level, 30 to 40,000 people are working to conduct the decontamination every day. And then that lasted for 5 years. So with that in mind, you need to supply almost 80, 90,000 radiation workers every day for several years. And there is no properly trained radiation workers beforehand. So most of the workers should be trained not only to conduct the usual remediation work, but also have to be trained for the radiation aspect, which means radiation safety, monitoring program, and others that, specific to the remediation activities. So those training should be applied before the radiation workers or remediation workers to be placed at the sites. So all those things are happening not only from MOE side, but also it is something like the labor agency that they have to be coordinated with MOE to develop those programs, and then have the monitoring program. And not only that, to supply those number of workers, a lot of contract system has been used, using usual public worker projects. So there is a primary contractor, and there is a subsequent subcontracts happening. And within those subcontract situation, there are so unexpected situations happen, sometimes some illegal workers getting in the job, and then or some illegal managers are taking some workers the money, taking away. And so Japan had to develop not only how to supply those workers, number one, once they figure out how to supply those workers, second thing is how to properly train them for remediation work at the radiation site. And then third thing is how to keep the actual the database that like to manage the subcontract, like 7-tier subcontracts, and also keeping track of the monitoring system that those level of those radiation workers. So those things, that's what Japanese government developed after the incident to actually apply those things. And that's, that already that is a difficult challenge to conduct. I will stop here, and then probably I'm going to ask Yoshinori-san for more up-to-date information.
Okay. Thank you for Sandunri. So it is responsible for Ministry of Environment Japan. So the ministry just shows the guideline to work, but not training worker. So it means it's no special program to certify that workers are properly trained, but so ministry shows a clear guideline, and ministry so train not train, but to tell how to do decontamination or transfer to ISF and so on. So it's just so not train, but it's a little guideline like so on. Yeah, thank you.
So does that mean that the training is the responsibility of each of the private contractors, the ones that collect the material, the ones that drive the trucks and so on? So it's the responsibility of private contractors to train workers, is that right?
Yeah, you're right. Yeah, thank you.
Okay.
Okay, thank you, Yoshinori. I don't know if we don't have any other question from the chat, but maybe I can ask any of you, maybe Yoshinori-san, you will be in a better position to respond to my question. I was a little bit surprised that all your presentations, by the way, all of them very nice, very interesting presentations, but any of them, at least I didn't see that, mentioned any role of the nuclear regulator in Japan, the Nuclear Safety Authority. May I ask you for that role? Are they playing a role, for example, to approve remediation criteria in terms of doses, etc.? Are they approving some specific technologies or not? Are they participating in public communication that will be essential to enhance trust, etc.? Maybe Yoshinori-san, we will be more than happy if you could help us in understanding the role of the NRA for this topic, please.
Yes, thank you for your question. So yes, standards is very important, but in Fukushima case, it is very special case. The Ministry of Environment is, of course, so regulation authority, but in Fukushima, Ministry of Environment do decontamination ourselves. Yeah, so it's very special occasion from other situation. Yeah, I think, for example, so I'm involved in the planning of how much decontamination work should be carried out. So at the time, it was a discussion about how many millisieverts should be decontamination. So it's very big discussion in the Fukushima. Yeah, thank you.
Thank you so much. Mark, do you have any question or
Yes, so one question,
Please.
Momose-san had talked a lot about the recycle, reuse of very low dose materials. And I was wondering, maybe Horst, if you could talk about any IAEA standards that provide overall guidance for reuse or recycle of low dose material?
So we need to establish important things here, and I not want to step on the toes of my colleagues in safety, but the point here is that clearance, as has been conceived, is something that is dedicated to plant exposure situations. So, for example, in the commissioning, you can think about clearance because the commissioning is a plant exposure situation, and the clearance applies for removing objects from an authorized practice. Remediation is a existing exposure situation. So, in principle, clearance would be not applied to that particular circumstances. But having said that, we had the chance. By the way, we conducted a series of, and that we missed to say, we conducted a series of 4 follow-up missions after the 2 missions that I talked about with MOE, where we had the chance to revise everything that was being done and had deep discussions about the different aspects that MOE put on the table for us to discuss. And all this experience is being compiled, and we will soon publish a technical document of the IEA bringing all this experience together. And one of the things that we talked about was essentially the possibility of recycling this material, because a lot of them would have activity concentrations that were absolutely marginal. And if I remember well, Sangdong, you help me, you are younger than I am, so your memory should be better. The concept that they were using was to establish not the clearance level for the activity concentration, but to establish a criterion in which once the material was used in a certain specific constructions, the dose that would be incurred by the population would be equivalent to a trivial dose of 10 microsievert per year. I think that was essentially what was being pursued. But I guess that we should really give attention to the possibilities to establish criteria for use of materials that come out from the decontamination works, from remediation activities. That is really much needed. Not sure if Sundong wants to complement.
Yeah, exactly. That's my understanding. If I add a little bit more information, I think the Momose-san can actually confirm. So decontamination waste is different from the different route of waste. Like in the ICSA, like the usual municipal waste can be also contaminated when the population generates or industry generates. And then there is a limit for which portion of the municipal waste that is radioactively contaminated goes to the ISF, and how much goes to the municipal waste stream, and that is 8,000 becquerels per kilogram. And then here is the different designated waste, which is the decontamination waste. So based on the special act of the special measure, any waste generated from decontamination activities, those waste should go to the ISF, regardless of the contamination level. And most of them, like what Momose-san mentioned, like most of them, like 80% or a little bit less, 80% of the waste is less than 8,000 becquerels per kilogram. And now the question is, like, it has the 2 different tracks of the radioactive waste, municipal waste and decontamination waste, and it has different paths. There shouldn't be different paths. And then what Horst mentioned was, okay, how do we utilize those soil from the decontamination that is potentially useful to the reconstruction, because many of the local governments are suffering from reconstruction from earthquake and tsunami in preparation of the potential next events, the next earthquake and next tsunami that can happen. But they need to reconstruct their community to protect from those events. However, there are missing piece, which is they cannot actually find the soil or construction material quickly. So some municipalities were actually looking for a way, and then that was, I think, a start of the more active communication with the MOE, like how to recycle those decontamination waste that is very low. And then MOE started investigating, how can we use this recycle or use this decontamination soil waste for the purpose of the public construction. And then criteria came up with, like, in the standpoint of the public exposure, and based on that exposure limit, what would be the protection level of the thickness of the soil to cover those the decontamination waste. And I think this is a background story that Horst and I, when we are communicating with the MOE for the IAEA mission, trying to add more information on top of Horst's talk. So maybe Yoshinori-san can actually add more information.
Thank you for Sandrine. So as Sandrine said, in Japan, so a large amount of waste are there, so generated by decontamination. So the volume is 1,400 cubic meter. Yeah. So we must dispose waste outside Fukushima. Yeah, by 2045. So it's limit. So it is a legal responsibility for our government. So, but the volume is very large. So we think it is very important to reduce the volume of waste. So it is the key to recycle the material for all landmark or road. So in Japan, Nagadoro district, we demonstration. We are doing demonstration for confirming the safety. Yeah, so it's very important thing. That's all. Thank you.
But if I may, Mark, just to complement, and there was also something on knowledge management that I might have, if I have time to shed some light. But regardless the criterion to be used, there is an element of social acceptance. And this is something that can only be possible if you have a strong stakeholder involvement, strong dialogue, so that all the angles of the situation can be clearly presented. And if possible, I know that the word may seem a little bit utopic, but some consensus is reached. But it's very critical when you call something that is contaminated with radioactive material to call immediately radioactive waste. It happens with norm, for example. In some jurisdictions, you call norm waste radioactive waste, and that imposes immediately a very big challenge in terms of perception, and we need to be very careful about that. But I want to underline that the decision about any recycling of the soil is not possible only by means of a regulatory decision. From what I sense, there would be a need for intensive discussions and involvement with the stakeholders.
Okay, thank you. I think that we are close to the end of our session. Is it correct? Is fine with you, Karen or Mark, please?
Yes, I want to thank you, Mark and Juan Carlos, for moderating this case study session. And I think these discussions really point to important challenges to successful environmental remediation that go beyond the purely technical challenges of remediation, and they're really important for us to consider. I also want to thank our Japanese colleagues, Professor Ozawa, Ms. Ando, and Mr. Momose. Your perspectives are critical to our discussions today. Momose-san, I especially appreciate that you stayed with us late into your night. Thank you so much for that. And then thank you, Sangdan and Horst, for your excellent contributions. And then finally, I'd like to thank our colleague, Mr. Yasuo Onishi, who cannot be with us today, but he contributed a great deal early on to the planning and success of this case study. So thank you all. We are into our break time, and I'm going to call the break now. We have 10 minutes. We'll start again at the top of the hour. And please come back. We have a great set of panelists talking with us about community revitalization. So strategies and approaches that can be adopted to ensure that we do a good job of helping communities that are adversely impacted by large remediation projects or nuclear accidents, for example, to rebuild and rejuvenate. So thank you, and we'll see you in about 10 minutes.
All right, hello everyone. Welcome back from your morning break. My name is Kevin Kautsky, and I will be moderating the first of three of our panel discussions this week. I hope you're enjoying the RemPlex Summit so far. This is first of its kind for us and has been very well received so far. And I hope you're making many virtual connections and getting all you can out of the presentations, case studies, and panels throughout the course of the week. So as I mentioned, I have the pleasure of facilitating the first of our three panel discussions. Today's focus is on community revitalization, and I'm excited about the group we have assembled for the discussion. So what can you expect for the next 90 minutes? So as far as our run of show goes, I'm covering some of the logistics and a brief introduction of each of the panelists. From there, we'll turn it over to each of them to provide some opening remarks and give you all a bit of context about their individual experiences and perspectives that they'll be bringing today. And then we'll begin the panel discussion. We also want you to know, if you've been attending, that this session will be recorded and be made available on the Summit webpage. So by attending today, you are consenting to this recording, and we really appreciate that. So we will be utilizing the Q&A function within Zoom today. So if you have questions throughout the course of the discussion, please enter those into the chat. As this summit has evolved, we're leveraging the Q&A function and potentially the raise hand function if we want to expand on maybe a question that comes in and wants some clarifying remarks around that. So we'll kind of roll with it that way. As with all things remote and technology, we just ask that you kind of roll with the punches. There might be some hiccups along the way, or a slide doesn't load or whatever, but we'll roll with it and we will make it work. So with that, I would like to introduce today's panelists. If we could advance to the next slide. And there they are. So I won't be going in the order of the slide. I'm going to be going in the order of alphabetical, because I don't want to play favorites because they're all my favorites. But so today we have with us first Michael Hulamard. He's currently a consultant and is the former executive officer for the Fort Ord Reuse Authority. Great to have you with us, Michael. Next, Seth Kirschenberg. He is the executive director of the Energy Community Alliance. Again, Seth, so happy to have you with us. And then David Replog, the vice president of federal programs for TRIDEC, the Tri-Cities Development Council, as well as the executive director of Hanford Communities. Great to have you with us, David. And I also want to point out my colleague, Mark Triplett, who's been instrumental in pulling this panel together. Has been a great help in he's worked with each of these individuals over the years in many different capacities, and has been wonderful in helping kind of pull this together. And then we'll be helping kind of co-facilitate this in terms of fielding some of the questions in the chat and making sure that we stay on time and I don't ramble on, which I can sometimes tend to do. So he'll be checking me behind the scenes on that. So with that, gentlemen, we're here. It's game time. So Michael, why don't you kick it off for some opening remarks?
Yes, and thank you for the introductions. With respect to opening remarks, I just wanted to thank all of the panelists as well, because this is an extraordinary group. And I want to say good day to all of you out there, because I recognize there are folks everywhere from Japan to the West Indies that are participating in this event. And community revitalization is a crucial issue for many, many communities across the nation, across the world. And in fact, there is what I call an intimate, intertwined relationship between remediation and community revitalization. Community revitalization, of course, you sometimes hear the political comment of all politics is local. Well, all community revitalization, whether it's regional like we did in the former Fort Ord in the Monterey Bay, or whether it's a small community in West Texas, or if it's a larger community like Anniston, Alabama, but still part of a remediation area. It's whether it's a small community, a large community, internationally or nationally, community revitalization is local. And in particular, it's because that's where it is the most passionate. So obviously, community revitalization is crucial in dealing with an area that has to be clean and safe for the community revitalization to occur. The big challenges have to do with the remediation and the connecting it to the revitalization. Those are some important things that every community must keep in mind, whether you are, as I said, a small community or a larger community, or even a state, thinking about the importance of that. So in most of our communities, we have to deal with federal issues, state issues, multiple local issues. They're all regulated by important folks that want to make sure that properties are safe. The acronymical linguistics that communities get into to try to understand these regulatory issues, and the technical components of cleaning a community so that the revitalization can occur is absolutely crucial. It's a part of that intimate, intertwined relationship between remediation and communities. And so if we can go to the next slide, I want to talk a bit about what we had to do at Fort Ord. The former Fort Ord was a very large military base. It was operated by the United States Army for about 75 years before it became obvious that the United States would have to downsize what it did with its military installations. And the former Fort Ord was a 45 square mile area right in the middle of a sub-rural region, which had predominantly agricultural and tourism as its predominant industries. That closure impacted the community in extraordinary ways. And so the revitalization had to figure out, how does the community recover? We use a former military base that had everything from munitions to asbestos to lead to PCBs to all kinds of interesting things that go boom in the night. Those major hazards and contaminant concerns sort of drove how the recovery would occur. And so if we can go to the next slide. I want to talk also a bit about how that had to happen. The former Fort Ord was part of a very crucial small region that was very diverse. It was a region that had impacts that had a large amount of infantry training. The former Fort Ord was originally called Camp Giggling. It was dedicated as Fort Ord in 1940s, but it was a basic training center for well over 1 million soldiers over the years, and every one of the soldiers had an impact on the environment. All military activities, especially the public training activities on former ranges, have a significant impact on the environment. So for all of that, as home to the 71st Infantry Division, the light fighter activity that occurred there was very impactful to the community. When the closure was announced in '91 and then officially closed in 1994, it had a very significant impact on the adjacent diverse communities, the African American community in Seaside that had grown up, the diverse community in the city of Marina that had grown up since the base opened, were all devastated by that. If we can go to the next slide. As you can see on this, those were the impacts. They were very important to our community because, as I said, all revitalization is local. And when you take an economic engine like a military base out of a region that was providing that economic structure, you have changed for generations to come how that community survives. So in our case, we had lost workforce, we had lost school enrollment, we had a complete change in diversity issues. The challenges to that had to do with everything from litigation to the fact that there were 9 or 10 different jurisdictions that were impacted, to the military's impact on the ocean that was immediately adjacent. And then behind me, I have as part of my screen, the ocean that is right next to where Fort Ord is in the central part of California. That had the Monterey Bay National Marine Sanctuary, which was being impacted by what was occurring. So many of that, and along with how the base was done, created a major conflagration, I call it, of what community could do to revitalize and to recover from the impact. If we can go to the next slide quickly. That regional agency that called the Fort Ord Reuse Authority was an attempt to have all of the local cities, which there were 8, the state and federal representatives, all the public agencies that were all stakeholders, plus the individual communities to be a part of the decision-making process. That's crucial because, as I said, all community revitalization is local. So it's important that those communities all participate, all those elected officials participate. At the same time, when you wind up with 17 to 25 elected officials on your board, it means that it's going to be an interesting political process. But with the authority and with the regional plan that was adopted, all of those activities could occur. And in a partnership with the regional, local environmental agencies and the federal and state local agencies, we were able to put together a plan that addressed remediation and fit it in an appropriate way with the recovery and the revitalization program. If we can go to the next slide. So we established a rather significant mission in 1997, and for the next 24 years until Fort Ord Reuse Authority expired under state legislation last year, that vision was how a community would grow up on that former base. And it wound up being done in a very sustainable way. And it couldn't be sustainable unless the environmental impacts of the hazards and all that were removed. But the focus was to have education as the center of mental recovery, that revitalization, and an economic effort that also capitalized on the agriculture and tourism of the region. And if we can move to the next slide. We did some important things. And when I say remediation and revitalization are connected, we did a significant amount of that revitalization in the local community under a contract for the United States Army. It was the first of its type where a local community under contract took on the obligation and responsibilities. And my friend Seth Kirschenberg will be talking later because he was a part of that great process as well. But we paralleled the work we did in revitalization with also taking on the remediation effort so that we could save having to clean properties twice, have it cleaned once for this and this for another. That meant everybody in the community had to watch that process, actively participate. The Army had to also recognize the importance of the structure. And as a consequence, with a $100 million grant, it actually cost us more than that to get it done. And saving the United States probably 50, 60, 70 million dollars and years of time, we completed munitions and explosives cleanup on a former military base as a local community, understanding that's still the Army's obligation. So we did a great job in doing that. That was a success. That was a part of our revitalization. We can talk more about that later, but with the panel. The next slide, please. As you can see, all of these properties here were getting ready to be held for maybe 20 years while the Army had to go through an annual process of cleanup. I only leave this slide here to show you how much of the property that was intended as part of the community revitalization of our community was impacted by munitions and explosives, and taking that on made a difference. If we can go to the next slide. These are some of the folks that got involved. When I talked about acronymical linguistics, that's just a cute way of saying that everybody had a different language. The terminologies were all different. We had acronyms being used by ATSDR, the Agency for Toxic Disease Registry, for example, and Substance Control, or the Department of Toxic Substances. All of those folks used different acronyms. And I used this slide just to show you all the acronyms on the right and in the middle, not to want to define all of them. But if you just look at the bottom, this is one of 67 different agencies that had some call or responsibility for regulatory or land use control on the former Fort Ord. That's the same as almost every other community has to define and organize. Next slide, please. So I say all of that to say, to go back to what I said before, community revitalization is local. It must be clean and safe to revitalize. There's an extraordinary amount of challenges. There are all kinds of parties that get involved. There's all of these acronymical linguistics, and it's very intimately intertwined, your success in revitalization with remediation and environmental hazard removal. But you don't know what you don't know, because starting into any process where you're dealing with remediation, you really don't know what's happening until you get there. So I'll pass this on to my coming colleagues, because I know they'll have quite a few things to tell me about this presentation.
Great, Michael. Thank you for that. Thank you for that context. And yeah, looking forward to talking more about that. Seth, I'd like to opening remarks from you.
Let me unmute myself. There we go. Hello, everybody. Thank you very much, Michael. It's always great to follow you, because you bring such great experience when you talk about the over 20 years of work on this. People need to realize this is every day. This was coming from people saying this project may not happen. This is going to be a very difficult project at the beginning of the process, and you were able to bring all of those acronym entities together to help make a successful project, which is great. I just want to take a step back and just give you a little bit about myself as well. So I'm a lawyer, and I'm also the executive director of Energy Communities Alliance. So I work on the policies related to assisting local governments with addressing some of these very complicated environmental issues, but also focusing on community priorities as we're dealing with those issues as well. And I'm focused at the Department of Energy sites. I'm also a lawyer who's worked on probably 40 plus military base closure reuses. And I've worked with a lot of other former federal and state property reuse projects. All of them have one thing in common. There's a lot of environmental issues that you have to deal with and address. And it was very interesting in the previous session. It is a key part of success of these programs and of cleanup by bringing in the community, understanding risk issues, and utilizing those processes in order to make a project successful. When Michael talked about Fort Ord, he talked about munitions and explosives of concern. He talked about the risk that existed. The community identified what needed to be done, and that's why they hired the contractors to undertake the cleanup. This was, as he said, a first of a kind project, because they wanted the project done within a period of time where they could reuse the land and decrease those risks. And they worked with the federal regulator, the state regulator, and the responsible party, the United States government, to address all of those issues and to work together to make them happen. I'll talk about that also a little bit at the Department of Energy facilities, of which I've had the chance to work on a lot of them. And what's interesting, I always tell people, it's one thing to talk about policy, it's another thing to have to do it every single day. And I've gotten to do that at probably about 45 or 50 of these different projects around the country. And it's been a great experience. So who's Energy Communities Alliance? We're the local governments and local communities. David Repolog, who's the next speaker, is one of our members. And we're a US-based nonprofit organization of the communities that are adjacent to or impacted by Department of Energy nuclear activities. And our goal is to make everybody work together. Behind me, if you can see my background, it's a lot of different reports and information that we put together, and some of the meetings that we put together on a regular basis to educate the community and the Department of Energy and the regulators and the states and the tribes and the community on all the various issues that we have to deal with at these sites. We've been around for close to 30 years, and we were formed by local communities, not the US government. That's one of the things that makes us successful. We work on a lot of different issues, whether it's dealing with cleanup to most of our communities, many of our communities want to host new nuclear power facilities, research facilities, and other types of activities. And we bring people together to talk about these issues and move them forward. So one of the things that I wanted to do when we talk about community revitalization and reuse of potential land or the workers who are at the sites, you've got to realize that there are a lot of benefits and a lot of different assets in a community. And so it's everything from the land to the people to the way that they work. There's a lot of usually incentives for working with former Cold War facilities, Department of Energy and Department of Defense facilities. That you have, rail lines that were used to ship major items back and forth between our communities. We have electric lines, transmission lines, grid connections that don't exist almost anywhere else that are already built. The easements already exist for those types of things. We have the people who work on the technologies. There's a lot of natural resources. There's a lot of known environmental characterization data that you don't have at other sites. So there's a lot of assets that we can that can potentially be used to attract parties to reuse our sites. When we also look at these projects, I always have to take a step back and tell everybody about cleanup goals because everyone has different cleanup goals. And so I just wanted to list those here and highlight some of them. There's only a certain amount of money. Parties are looking for different things about how to actually get these sites cleaned up and reused or have the community develop a reuse project. Everybody has different incentives, and once again, we try and highlight these here, but what we're trying to do is help everybody reach their objectives with these reuse and redevelopment actions. One thing that we talk about is cleanup, and it's interesting because right now the Department of Energy uses the term end states to define contracting. And what we try and always identify is that people look at it differently. The contractor's going to look at it as their scope of work on the project. DOE looks at it as the contract management tool. The community looks at it completely different. We look at it as the expected outcome. And if you look at how end states is used in those contracts, they're very different and they don't necessarily meet what the community wants as we're going forward. And so we have to always work on those things and work on the language. Just as we're working on acronyms and teaching people, we're also trying to teach them, the use of words as we're moving forward. One of the things is, and I talked about and identified all the different cleanup family members, I call them. They have different objectives and different definitions of success. But at the same time, what we're trying to do is harnessing and bringing them all together to create those consistent goals. So the Department of Energy, it has a process for potentially acquiring some of their property. And it's a very simple process, but it's not a simple process. I've seen it take where the Department of Energy really wants land conveyed and where the contamination is, minor, or not by minor, I would say, things like asbestos in the buildings and minor contamination in the land. I've seen it transferred within 3 months. Most transfers take years. David's probably laughing hysterically, having been through this many times. And same with Michael. It usually takes a very long time to go through this process. But the key thing for community is identifying why they want to use why they want the property and why they want to use it. Michael went through a multi-year process to plan the reuse of Fort Ord, and that's what they do at base closure communities before the reuse. And I think David's been through a lot of similar activities. You have to identify the property. So there's different items and there's different issues with each of the properties, depending on where they're located. Sometimes there's existing parties who believe that that property was taken from them. Sometimes there are issues related to how much the environmental contamination exists on the property. Sometimes there's natural resource issues at the property. So you need to understand all those different things. Identify the needs, the timing, those types of things. Then you can request the property. The department has a process where communities and CROs, community reuse organizations, can request those properties to transfer them at no cost. And the Department of Defense has a similar process where it's, there's a valuation called an economic development conveyance. And there are other processes. Sometimes we use special legislation to move these properties forward. And then the terms have to be negotiated as you move forward. And then the property is acquired and conveyed. I just lay this out because that's a general reuse and acquisition if there ever is, and there's an interest in acquiring different federal properties. Some of the lessons learned, and I know we're going to get into this in discussion, so I'm just going to generally say this, is the important thing is to set the goals. All of the parties need to set the goals that I listed. It's not just the community that's acquiring it. What is really the goal here? The law is critical as well, because that's the process that's going to be followed as we're moving forward. Michael talked about why the community undertook the cleanup. There's something called ENCIRCLA, the environmental cleanup, one of the environmental cleanup laws that allows for covenant deferral, which allows for property to be transferred as long as EPA and the state have signed up on the cleanup plan, and they can identify that the funds are available for that particular cleanup. And everybody works on it in order to move things forward. And it got private cleanup to move, a private contractor to come in and clean up the site quicker. And then education's critical. The last panel talked about it, making sure there's community support and buy-in. And then leadership really sets the tone on all of this. If the Department of Energy wants something done, it happens. If the Department of Energy leadership doesn't care about it, it may never happen at all. And sometimes that leadership comes from Congress, sometimes it comes from within the department, sometimes it comes from other places. So the other thing is, I'm going to leave this because a critical piece, I just want to highlight some of these things, are defining acceptable risk is a critical issue as we're going forward when we talk about cleanup. And this RemPlex is about cleanup, and risk is different things to different people. It's really critical. The minimum of the law is never enough. So the minimum of the law defines how to involve communities and those types of things, and that's never enough in order to move forward. I just want to end it with, thank you. I look forward to the discussion, and if anybody has any information, anybody has any questions, they can reach me at that email address.
Great, thank you, Seth. All right, so for the last of the opening remarks, we'll transition over to David and then get to the discussion. David, the floor is yours.
Hey, greetings. I hope that everybody can see my my slides here.
Yep.
And it's good to be on a panel with my good friend Seth, who, as he noted, I work with on a very regular basis on a variety of Department of Energy and Energy Community Alliance related issues. And good to get to know Michael a little bit through this process, and really appreciate the chance to share sort of a case study of some of the things that we've done in the Tri-City area near the Hanford site. And first, I might start by setting the stage a little bit, in case you're not familiar with the Hanford site. Hanford was created in the early 1940s as part of the Manhattan Project during World War II. It was made to produce plutonium for the bomb, first the bomb that was tested in New Mexico, and then the nuclear weapon that was dropped on Nagasaki, Japan during World War II. And then it really ramped up after that during the Cold War, ultimately having 9 different plutonium production reactors over the course of the history of the Hanford site. At that time, the focus was on winning the World War and winning the Cold War, not so much on the environment. And as a result, when the transition happened from from production to cleanup in the late 1980s, there was a lot of work to do, and there was a lot of work still to do, decades worth of work still to do. Many considered the Hanford site to be one of, if not the most contaminated sites in North America, perhaps the world. The communities surrounding the Hanford site are the cities of West Richland, Richland, Pasco, and Kennewick. It should be noted, though, that they're not, for the most part, immediately adjacent to the site or to where there's contamination. It's a good probably 25 or so miles from the Richland city limits to the more contaminated parts of the Hanford site, although there are some locations a little bit closer to town where there is some contamination that is being remediated as well. And I'm here wearing sort of two hats, as Kevin mentioned during the brief introductions. I served both as Vice President for Federal Programs for TRIDEC, the Tri-City Development Council, which is the economic development organization in the Tri-City area, as well as Executive Director of Hanford Communities. And Hanford Communities formally represents the local governments on cleanup related issues. But since the focus of this conversation is more on community revitalization, I'll be sort of wearing my TRIDEC hat more than my Hanford Communities hat, although they certainly overlap quite a good deal. And with that, if I can make this work, there we go. A little bit about TRIDEC. It was established in 1963. It was originally called the Tri-Cities Nuclear Industrial Council. And at the time, the economy of the Tri-Cities really rose or fell almost entirely based on how much Congress appropriated to the Hanford production mission at the time. And so some local business leaders and the publisher of the local newspaper came together to form this Nuclear Industrial Council with the idea of advocating for continued funding, but also to increase the diversification of the local economy. And I think what's notable about their approach back in 1963 was that they really did take a regional approach. At the time, the Tri-Cities, the four cities, I think it was probably only three really, at that time, they were both geographically and economically fairly far apart. They've grown much closer together in all those respects more recently, but they did take a regional approach, and one that I'll speak to more later, but I think has been really a key to the success. In the mid 1980s, TRICNIC, as it was, merged with what was then the Regional Chamber of Commerce to form TRIDEC, and it became more of a traditional economic development organization, but still maintaining that federal advocacy piece that really it began with and continues to this day. And Seth also mentioned community reuse organizations, and in 1994, TRIDEC was established as the community reuse organization for the Hanford site. We have about 300 members, and we have economic development contracts with the 4 cities, 2 counties, and 3 port districts in the Tri-City area. One of the keys, again, and I'll probably say this several times, but is speaking with one voice and advocating together. And so that's exemplified, I think, in our board of directors. We have a 42-member board of directors, which is pretty large, but when you have so many local governments and large employers in the community, you sort of need to have that many to have that broad representation, which again is pretty critical. So we have, I won't go through all of these, but we have all the local governments, the Hanford prime contractors, Department of Energy managers, as well as large employers, higher ed and others from our community that are part of the board of directors. But all of what we do and all of what we've done since 1963 has been in partnership. Partnership with our local government partners, with other business organizations in the community, with the state, and especially with our federal congressional offices, and to some extent also with the Department of Energy as well. And some of the things that have been accomplished, again, I won't go through this entire list, but just to kind of give a few examples of the things that have been worked on and sort of led by, or at least with heavy participation by TRIDEC or its predecessor, establishing interstate access to the Tri-City area, the growth and expansion of the regional airport. There has been and continues to be, as Seth sort of alluded to, a real focus on nuclear technology, civil nuclear technology, including the fast flux test facility that operated on Department of Energy land for about a decade or more in the 70s and early 80s. A real focus on the continued growth and success and diversification of the Pacific Northwest National Lab that is a key part of our economic future as a community. But also work to really grow and diversify the economy. And that is also a continuing theme. I was born and raised in the Tri-Cities, and recall even during the 80s and early 90s, whenever there was a major layoff at the Hanford site, people left town because there was just no other opportunities. And so all of our partners and TRIDEC have really made a concerted effort to grow and diversify the economy. And that's taken a lot of different shapes. The Tri-City area is in the middle of a very robust agricultural region. We grow a lot of fruits and vegetables that people eat every day, apples, potatoes, everything else. And so there's been a real focus on food processing to meet sort of the lower skilled workers, but also distribution. The physical location of the Tri-Cities is near some major interstate highways, so makes distribution a logical industry for the Tri-City area, but also really leveraging the scientific and the technical expertise and the highly skilled workforce that we have because of Hanford and because of the National Laboratory to do other things in the research and development, demonstration, deployment, and other opportunities associated with advanced technologies with a particular focus on energy. One of the sort of unique things about the Tri-City area is you can drive 30 minutes or less and physically touch 4 forms of clean energy, whether it's nuclear, hydropower, wind, or solar. And so we have a really kind of unique capability there that we're looking to continue to leverage. And we also partnered very closely with our community, our fellow Manhattan Project National Park, or Manhattan Project communities of Oak Ridge and Los Alamos to establish the Manhattan Project National Historical Park in 2015. We also do work very closely with all of our community partners to again speak with one voice when we're engaging with Hanford contractors. There are 4 prime contractors at the Hanford site and a number of subcontractors or other LLC partnership organizations. And part of their contractor commitment is to establish this community commitment clause or community commitment priorities, where the contractors will sometimes invest some of their award fee in different things within the community. And so we worked with all of our community partners to put together this community commitment priorities document that identified a number of the top priorities. And again, that document was approved by and put together in coordination with all of the local cities, counties, ports, business organizations, and others in the community. And one of the real focuses has been and will continue to be workforce development. We really recognize this as a win-win both for the community and for the Department of Energy. When you look at the needs of the Hanford site, of the National Laboratory, and of the community in the decades to come, having that workforce that's capable of stepping in and doing the job in the future is critically important. And so that takes the shape of baccalaureate and post-baccalaureate programs, but also especially in the skilled trades, and then reaching down to the K through 12 in support for STEM education. One of the other things that we really focus on is we do have a pretty robust small business subcontractor community in the Tri-Cities. And one of the focuses is to ensure that those subcontractors are able to be successful kind of with or without the Department of Energy's mission. And so although we certainly want to have them continue to be successful and to work to support Hanford cleanup, if that funding goes away, how do we give them the tools that they need to also diversify and to develop customer bases and skills and expertise outside of the Hanford cleanup mission? So that's been a real focus of ours as well. And then lastly, but certainly not least, technology transfer and commercialization, especially of technology that's being developed at the National Laboratory here in the community. I also wanted to mention a couple of, I think, pretty significant government partnerships that we've had in the Tri-Cities over the years. One was a grant that was called the Hanford Workforce Education and Training Initiative. It was a 5-year, $4.5 million grant. It established a couple of important programs at our local community college, Columbia Basin College, the Nuclear Technology and Project Management programs, as well as the Health Physics Certificate Program. Again, these are win-wins, both for the community and for the Department of Energy's missions here. And then again, as part of the partnerships with the contractors, there's a number of mentorship, internship, and educational outreach programs. And then as again, Seth sort of alluded to, as the community reuse organization, we have traditionally been able to take possession of excess personal property, meaning anything from computers to furniture to sometimes machinery or whatever it might be that's no longer needed at the Hanford site, and use that, auction those items and use the proceeds, which over the last 20 years or so equal up to about $4 million, and use those to incentivize businesses to either come to the Tri-Cities or to expand their operations here. And it's led to the creation of about 1,625 permanent jobs and about $775,000 in matching dollars from the state of Washington. And I think one of the keys here too is that although our economy has become a lot more diversified and the community has grown very substantially in the last 20 years, we're at about 310,000 people now. I think 20 years ago, we were maybe at 200,000. So it's grown very substantially and have diversified, but we still frankly face some challenges associated with being so close and being so closely associated with Hanford and nuclear waste. And so sometimes that leads companies to maybe shy away from locating here. So having that tool to recruit and to incentivize their location or their expansion here has been very key to a lot of the success that we've had. And then lastly, I wanted to quickly just touch on some of the land reuse. So when the Manhattan Project was formed, all of the city of Richland actually became federal property. And in 1957, the city of Richland proper, the Richland city limits, were transferred back to a new incorporated city. And so basically all of the city that I was born and raised in and I'm speaking to you from right now was former federal land as part of the then Atomic Energy Commission's work at Hanford. But more recently, the Tri-City Research District, which is outlined in the map here on the slide, has been established by our partner, the Port of Benton, and with a real focus on that technology transfer and commercialization, being in close proximity to the National Laboratory, and also having the Washington State University Tri-City campus as part of the research district. And then several other areas, including the 1100 area, 3000 area, and our fairly small general aviation airport, the Richland Airport, that's in land that was previously owned by the Department of Energy, have all been redeveloped and used for commercial and economic diversification purposes. And then most recently, in 2015, 1,641 acres of land that was owned by the Department of Energy to the southern part of the Hanford site, very close to the Richland city limits, was transferred from the Department of Energy first to TRIDEC as the community reuse organization, and then from TRIDEC at no cost to our partners at Energy Northwest, the Port of Benton, and the city of Richland for the development of a clean energy park, really again focusing on the research, development, demonstration, and deployment of clean energy technologies. I think the first real opportunity there will be a solar farm on about 300 of those acres, but we have a number of other really exciting opportunities that we're exploring with the remainder of that land. And so with that, again, I thank you for the chance to be a part of this panel and look forward to the rest of the discussion.
Great, thank you, David, and thank you, everyone. Great context setting for your experience, your background, and leading us into some of the themes we discussed and kind of preparing for this. So we had talked about three overarching themes for the discussion around: one, the evolution of trust; 2, balancing and embracing the diversity of community interests, and 3, creating a vision of the future. And I think each of you in your remarks have touched on elements of that, but I'd like to circle back to kind of start the dialogue. And again, this is a discussion, so I'll kind of introduce the question, but encourage, while I'll ask one of you, as others have thoughts, please to weigh in on that, because I think there's a lot to be shared here. So Michael, so in that theme of evolution of trust, what were some of the biggest challenges that you faced during the forward remediation and reuse planning and implementation? You touched on a few of those, but what were some of those really big challenges when it came to evolution of trust?
Thanks for the question. And that actually touches on one of the questions that we received from the participants during the presentations. One of the really most difficult things to do in any community revitalization is to focus the community's attention on what the full scope is and what is required to undertake a revitalization effort, and why many things they would like to happen might be prohibited or barred because of certain circumstances. When you talk about trust, the communities across the nation, for lots of reasons, maybe historical, some of us think there are 4 centuries of mistrust that have occurred having to do with diversity issues. Others will tell you there have been a couple of centuries of the Industrial Revolution that requires thinking of environmental reparations. There's mistrust. Building a trust with local communities is tough, and often because the local will resort to legal efforts to try to bar things that can be paths forward. So I'm going to look to my colleagues Seth Kirschenberg and David to talk a little more about the legal issues, particularly because there's an ESQ behind Seth's name. But I think there are 4 areas where trust is usually thought of, and that is, how do you communicate and educate? How do you engage the local community? By going to neighborhood meetings, by using the press, by maybe thinking about websites or about blogs, or how do you manage to make that happen? And of course, the answer is you talk to people where they communicate, wherever that is. That's, I think, the first step to sort of building trust. The second is, when folks start thinking about using legal means, think about methods of resolving those. The first thing you have to do is make sure that you're doing a project, whether it's a new physical construction project or a cleanup project, or maybe it's simply a zone or a code. Are you doing it in a way that builds trust in the community by looking at the other regulations, looking at how it addresses community interest, and communicating how that's going to help impact local communities? There's another way to do those kinds of things as well, other than we've done in the past. When you get to legal challenges, sometimes it might be better, instead of taking it all the way through a court decision, is to think about mediation. Think about sitting down and structuring ways for things to move ahead. In some cases, where we have restrictions on property, a land use covenant that says you cannot use this property for these purposes, but the community wants to do that, we work with the community and the regulators to think about how we can maybe place a new covenant restricting the use of property in a way that says, here's all the things we'll do to get to where you need to go. So with respect to resolving legal challenges and building trust, sometimes those things are very much intertwined, but you have to be believable, because quite frankly, the first time you breach that trust, it can be something small. That winds up being front page news, and that's what folks are going to remember, rather than the 100 days before where you did this right and that right and that right. You have to be committed to the community, and you have to demonstrate in a believable way that you're supporting that community. So the evolution of trust is crucial to being successful. We found that at Fort Ord, but I can tell you from visiting 100 sites across this country over the last 15 years, it's true in every single case. Building that trust is always at the heart of a successful recovery program, a successful revitalization program.
Right. So Seth, along those lines of evolution of trust, what are some of the barriers that you've seen faced, and how were some of those overcome?
It's interesting. One of the first things that is done in order to make these projects work is an organization is set up really to be the point entity. And Michael talked a little bit about his organization. David talked about his. But what you saw was two different things. One is that the community kind of came together and defined what that organization was going to look like. They, in Michael's case, they negotiated a little bit before state law was passed in order to structure that organization. I represent, local governments where the facility is 100% within their community, like the District of Columbia, or in San Francisco, where we're at Hunters Point and Treasure Island. And then I've worked with communities where there are multiple, communities around it, like Fort Ord and other places where organizations had to be created and they came together. When you look at both base closure community reuse or Department of Energy reuse, there has to be that one entity that's kind of the lead. And David talked about it, is everyone kind of coming together to be able to speak with one voice, to be able to focus everyone's attention, to create that trust as you're going forward, to create where are the meetings going to be held? How are you going to communicate with the public? How are you going to make all of these different pieces come together and work together? And so, when that's usually the first step when I look at this. And when I talk to people, we have a lot of international visitors coming in talking about what they want to do in their particular projects. A lot of times I tell them that they need to create these organizations, but they can't be created from the federal just telling people what they're going to do. If they want them to be successful, they also have to come from the ground up to get that buy-in. And then that helps also the community already has the relationship with the council members, the mayors, the city county managers, those types of folks. And sometimes I see these groups also include Pueblo or tribal participants as well that are really critical. And then the federal agencies, when they focus their funding to create these organizations and capacity, they also have a source to go to that's a governmental entity that's supported by the other parties. I know I didn't answer your question directly, but I think that's a critical piece, as we're kind of going through and looking at these particular projects.
And I think the flow of the conversation is exactly along these lines, and it goes back to what David teed up in terms of that one voice concept. And so David, within that evolution of trust theme, so having been a Tri-City resident many years of my life, and knowing the diversity of interest when you've got three cities that are in the same location but not always necessarily sharing the same interest, and sometimes there's what I'll call co-opetition that is bred with different community interests. So how has TRIDEC maintained the trust of the many interests it represents to maintain that focus on one voice?
Yeah, and maybe before I touch on that too, I'd like to just quickly speak to that establishing trust question as well, kind of more broadly from the Department of Energy perspective. Because again, as somebody who grew up in the Tri-Cities, I recall driving by the park that's in front of the federal building here in Richland and in the 80s and seeing people protesting. And there was a ton of distrust towards the Department of Energy at that time period. And I think as it was sort of a rough transition for really a decade or more as the site moved from production to cleanup. And I think one of the real challenges was, the site had operated under a very thick veil of secrecy for decades. And there were times where everybody who worked at the Hanford site needed to have a top secret level clearance. And it took a while for the Department of Energy, I think, to kind of get used to the idea of being more open and sharing information. But I think they have evolved a lot since those days. And I think there is a lot more of that trust and a lot more of that openness that helps a lot. But that being said, there is still a lot of, there's a lot of parties who were involved in Hanford cleanup. There's a lot of stakeholder groups. The Hanford site was certain parts of it at least were very important to a number of regional tribes. And so as we look towards the future and how do we successfully complete the cleanup, I think there's still a lot more hard conversations to have and a lot of it, I think, goes back to something that Seth hit on, which is the acceptable level of risk. What's the end state that we're comfortable with? And then who do you trust, or what entity, combination of entities between the agency, the regulators, third parties that that will be a part of that decision-making process. But going back to your actual question, Kevin, I think one of the things that we've seen is that, in many respects, kind of, at least in this community, a rising tide lifts all boats. And so if that means a large, say, distribution center is located in Pasco rather than Richland or Kennewick, well, the people who work there might live in Pasco or Richland, or might live in Kennewick or Richland. And so it still benefits those communities. Likewise, with the Hanford site and with the National Laboratory, in many respects, our community has been blessed by the fact that those jobs are fairly high-paying jobs. They're good, solid, reliable jobs for the most part, at least in recent decades. But the people who work at Hanford, although it's closest to the city of Richland, they might live in any of the other communities. They certainly spend their money in different communities as well. And so I think part of it has been that recognition that the rising tide does lift all boats, but also I think it's been working in a really good faith effort. I think TRIDEC doesn't have any favorites, and we make it very, we make a very clear and intentional effort to work just as closely with all of the entities that are in our community. And then I think the fact that all of those entities also are on our board of directors and get the updates and have a chance to steer the organization as board members, both the elected officials as well as senior staff from the local governments and the other some of the other leading employers in the community. I think that ownership and buy-in and active participation has been critical as well.
Great. So kind of along these themes, Seth, I think you teed it up nicely in your opening remarks in terms of, I guess what I frame it in terms of not making promises you can't keep, or not over-promising. And I think the idea of, you framed it with setting your goals, knowing the rules and actions for all the parties involved was a nice way to look at it. So when looking at that, and kind of open question for all of you, what are some of the best practices in terms of building that consensus when understanding how to leverage potential remediation investments and reuse of remediated land? What have you all experienced in terms of how do you, the idea of consensus is a good idea, but getting there sometimes is a bit of a journey. So, and to Seth's point earlier, sometimes there are rules at play that those might have a certain vision, don't understand that there's just certain requirements either the agency is required to meet, or it's just quite frankly not possible in a community. So what are some of the best practices along those lines of, okay, there's an opportunity here, how do we get on that proverbial same page?
I'd be happy to start. I know Seth is just going to be chomping at the bit to talk about this one, but I happen to have 25 years of experience as executive officer in an organization that required unanimous consent by the voting members anytime an issue came before the board, or you had to wait for a month to take a second vote, which sort of forced the idea of consensus building in the process. That required an extraordinary amount of communication. It required a significant amount of doing the process correctly the first time and making sure that people weren't left out, that all the stakeholders were brought into the process. I don't know that I would recommend to the state that they would structure an organization that way ever again. Because after living with it for a time, I would say sometimes the delay didn't get us what it wanted. Rather, it opened up an opportunity for a debate that was unnecessary, or it offered up an opportunity for somebody to take a shot at someone on something that was not related issue, just to be able to use the leverage. So it's a good in theory, and it's good in thought. Building consensus, I'll all for it, but expecting consensus is not a good thought for or a result to get something done. So you balance that with the need to get something done, because there are people out there that may not have jobs, that may not have an economic support, or there's a homeless issue. There really are higher issues that we should focus on than consensus, even though it should always be a focus and a target. So I'll just start with that and let Seth take it over.
So first, there's never smooth sailing in any of these projects. You know, no matter what anybody tells you at the end, they all say, look at what we accomplished and we got all this done. And yes, those things are true. But when you remind them of the discussions that occurred and the processes that occurred, they're very difficult. And it takes a lot of working together. And, you know, I would say that, you know, you need to get everybody to focus on a goal and focus on a process. What's really interesting in the DoD process, what I do love about it is it's a process defined by law. So it tells everybody you're going to do step 1. When you're done with step 1, you go to step 2. When you're done with step 2, you go to step 3. And there's a process for each one in order to what you see as the end result. And it's not an easy process. It's very difficult, takes a lot of community consensus. There's a lot of remediation issues. There's a lot of appropriation issues, authorization issues. Every single one of these processes, there's been a change in law 16 times throughout to change those rules and processes. Michael got to testify before Congress probably at least five different times on why to change some of these laws and these rules. But getting that process helps. In the DOE communities, in the early years, there was a process. There's no process now. And so the community has to create that process, because it's very rare that the department is saying, you know what, we want to help you create this revitalization program or this process. Most of the time, it's the community going to them. Sometimes the contractor will help come up with the idea because they see to accomplish their goal that it would help for the community to create a reuse. And obviously, most of the contractors live in our communities and want to see success also. So I should say that as well as they're going forward. But in our communities, we have to create that process. And what we do is they create that goal, we identify it, we put it out there, and we move on that process and we move it forward. A lot of times we will create new rules that I identified a particular law, 10 CFR 770. ECA is the one who created or helped push to create that law and that process, just like there are other things that are out there where we do that. The remediation has a process. So CERCLA has a process, RCRA has a process. And so that is somewhat defined, and you're trying to plug in these other pieces into that. And so, you know, it helps if someone helps you or helps the community define what the process is going to be, helps bring the federal agencies, the regulators and others who have that input, and the appropriators and the funders into that process and create that process going forward. I think that's one of the key things. And then the laws help define some of those as you go forward.
Yeah, and the one thing I might add too is, as Seth said, the cleanup remediation decision-making process is pretty well defined. And so we take an active role, both wearing the TRIDEC and the Hanford Communities hat of providing input, but also with Hanford Communities, one of our missions is also to better inform the local public about what's happening at the Hanford site and opportunities to provide input. So we'll share those opportunities either via social media or on our website, and really encourage people to be an active participant in that decision-making process. Outside of cleanup related decisions though, you know, again, because we have so many different entities in the community, especially when it comes to economic development and revitalization sort of issues, TRIDEC has always sort of played a community leadership convener type of role as well. And so numerous times over the years, we've convened just open houses or public meetings or listening sessions to present an idea or a concept, and so basically just sort of get public input. And with the idea that if people have the chance to both better understand whatever is being considered and feel like their voice is being heard, both that helps to guide the decision-making process in a very meaningful way, but also it creates that buy-in and that sense of that greater consensus as we make those decisions.
You know, Kevin, I think those comments also remind me that, particularly in terms of thinking about the diversity of community interest and balancing all of those, there's often in these communities, they are, I would say, multicultural is one way to phrase it. Whether you're in San Antonio and it's a Mexican American or a Hispanic community, whether you're up with the Umatilla Native Americans and the Columbia River Gorge, or if you're in my community in Seaside, where their African American community is very concerned, you're winding up with issues in the remediation process that enables the revitalization of issues associated with environmental justice. Oftentimes, there's still that residual trust issue because some of these contaminants, whether it's Hanford or whether it's Fort Ord or whether it's Fort Monroe, wherever that contaminant is, those communities are often multicultural. What used to be called minorities are being impacted by these hazards in some way, because at least they're exposed to the safety issues associated with remnant asbestos, remnant lead-containing materials, and so forth. I think it's crucial that we understand those communities are often also thinking this environmental issue is taking over our lives. They're not providing jobs for us. They're not thinking about the fact that remediation enables us to get real jobs and get a part of the pie. And we have to make sure that when we do think about balancing community interest, we don't accidentally leave folks out that create more trust problems, as you asked before, in the process. I just want to reiterate the importance of the diversity of community interest being understood, the process being evolved, and the environmental justice that's required in the process is engaged.
Yep. No, great point. And actually, I'm glad you said that, because there's kind of two thoughts and then the question. So what you hit on is exactly, the thinking that went into the summit about how we wanted to structure these panels discussions overall, because this is the first of 3. Tomorrow we'll be diving deeper into an environmental justice discussion and then a community engagement discussion to follow. And so there's a lot of interplay, obviously, between a lot of the discussions we've had to this point, but kind of building on our themes for today with the moving from building trust and then the diversity of community interests, that very definition of community, and Michael, I think you hit on it right away, is each region, each area, each individual group, each individual human being is going to have a different view of community. So what are your thoughts, for the panel in terms of how you've kind of identified that, sometimes a remediation project, we don't want to look at these projects as to heal all of society's ills, but we need to understand that coming into a community, there has to be an understanding of what it is that makes up the very fabric of that community and building that trust. So thoughts that you've experienced in identifying what really is the definition of community.
Yeah, and my whole career has been focused on somewhat of that question. Be early in my career, I worked for ICMA and I served on the committees that set up National Environmental Justice Action Committee, Brownfields, the Federal Facilities Environmental Restoration Dialogue Committee, Defense Environmental Restoration Task Force, and a lot of other groups that kind of focused on that issue when we're focusing on remediation and cleanup and other things. And I will say that, I actually try and have the community define what the community is versus someone else trying to define it. I know in our communities, we always focus on, the people who are actually impacted by the cleanup. Those are the people who are usually local and they live there. Sometimes they're downstream as well. Environmental issues are never just in one area. But what we focus on and is the communities that are the most impacted by the environmental issues, the job issues, the economic issues, the socioeconomic issues, all of those different types of things. And we, when we're talking about revitalization and reuse, we try and bring all of those together. At some of the Department of Energy sites that were closed, whether we're talking about Rocky Flats, Fernald, Mound, Pinellas, those types of things, that issue came up a lot. In Rocky Flats, what you had was you have a lot of surrounding communities with a lot of different interests. You had the workers in one area, you had people who had nothing to do with the site in another area. And for them to create their group and their organization was very difficult. But once they created it, it was something where there were a lot of disparate discussions, throughout, because you had some wanting to reuse the site to replace the jobs that were being lost. In others, you had, just wanting open space. And it took, at least 10 to 15 years to resolve those issues. When I worked on the Hunters Point in San Francisco, the Hunters Point's located in a predominantly African-American community, but it was all within the location of the city of San Francisco. But when you went to the community and you focused, and by that time, I mean the community, the people who lived adjacent to the facility, they were the most impacted by everything. A lot of the people who worked there, they were the people who worked on the site, contaminants, they were the most impacted by the contaminants of the site. And they wanted to make sure that they had a benefit from the reuse. And so there were a lot of discussions by the supervisors and by the city staff on how to make sure that that occurred. And the community was never going to let us not take that into account and to push those issues as we move forward. So that's my long way of saying the community really has to define it, and the federal government cannot.
It looks like we lost Michael for a moment there, but we have him back. So, so David, along the lines of the defining community, I know, as you kind of alluded to with the opening remarks, that the Tri-Cities community can be rather diverse, many different interests and such. And, again, having grown up there, knowing that each different city can have a very different demographic makeup. So how has TriDec approached really, back to a little bit of the one voice, but really that how does TriDec define community?
Yeah, and I think as it relates to being a part of the cleanup decision-making process, I would echo what Seth said, that I think a lot of it has to do with communities that are actually impacted by the decisions made about cleanup, whether the communities immediately adjacent to the Hanford site, like the Tri-Cities, or again, the tribal communities in the region that have any number of reasons to be very invested in the cleanup decision-making process. One of the things that we've seen is that there are some other organizations that are outside of the kind of the immediate area that also play a very active role in making those decisions. And it is the Hanford site is a major federal investment, and it's a federal project, and so everybody should have an opportunity to be engaged and be a part of the decision-making process. But part of that decision-making process, I think, does need to recognize that there are some that are uniquely kind of impacted by the decisions, and make sure that they are an active part of it, regardless of who else is also part of the conversation. And I think one of the challenges with any community that might be engaged is, one, you need to actually get out there and do that engagement. Sometimes it can be challenging to get people's attention. They have a lot of things going on in their lives, and it can be hard to focus on Hanford cleanup decisions, but also being able to explain it in a way that makes sense. I've been working on Hanford issues for, I want to say, probably 15 years or so now. I don't have a technical background, but a part of a lot of those conversations, and when there's discussions about the level of remediation and risks, and when you're using picocuries and nanocuries and lots of exponents, that's really hard for your average person to understand. And so I think one of the things, I don't mean to say dumb it down, because that's not the point, but use terms and discuss it in a way that it's tangible. Why does this matter to me? Why does it matter to my community? And so I think that's one of the things that we continue to encourage DOE, the contractors, and the regulators to do as we look at future Hanford cleanup decisions. And to the second part of your question, Kevin, about how does TriDec engage with kind of the diversity throughout the community. And I think that's something that we're really, making a very intentional effort to do, and we have been for years. But I think we've had, especially in the last couple of years, with some of the CARES Act grants and some of the partnerships that those have sort of created, we've I think strengthened our bond with some of the other chambers, including chambers that represent kind of more diverse communities within our community, groups within our community. And then also as part of some of the other efforts that we're undertaking that are kind of outside of Hanford Cleanup, we've had a chance to engage with some of our regional tribes in a much more, I think, meaningful manner than we have in the past, both to discuss those particular issues, but also to have broader conversations about where they're, again, I'm a big believer in win-wins, when you can find opportunities where everybody wins. Even if the tribe might be 50, 100 miles from here, there might be some opportunities. And so let's just talk about what you folks are looking at, where your opportunities might be, and how they might align with what we're looking at, where our opportunities might be, whether it's in workforce training or complementary supply chain manufacturing, whatever it might be. And so I think that's something that we have been working to do, and certainly want to do more in the future.
Great. So as expected, we're moving through this 90 minutes rapidly. Yes, we've got about 16 minutes left in the session. So I did quickly want to get to some of the questions that did pop in the chat, and then give you all the last few minutes to kind of close out the session with a focus maybe on kind of this theme of creating a vision for the future. So the question that was in the chat, or kind of the statement here, was the panelists have had valuable experience with both DOE and DoD revitalization efforts. Are there authorizations that one agency has that other agency doesn't, that would help facilitate, expedite realization of community goals? Looks like, Seth, you'd kind of responded in there, so I don't know if you want to.
Yeah, I've hit upon a couple already, but one of the things that Department of Defense have is an office called Office of Economic Adjustment. And that office not only helps with closing bases, but also helps with active bases. And there's a focus on it. What's interesting, the Department of Energy has nothing like that. It used to have something that was somewhat similar. The Worker and Community Transition Office that was shut down early 2000s or somewhere around there. But the Office of Economic Adjustment actually provides funding for communities. And so where EM is responsible for its piece, Office of Science, its nuclear energy, its piece, NNSA, its piece, and their missions, whereas the Office of Economic Adjustment is focused on these issues very specifically and helping communities, but not helping communities for the sake of helping communities. It's helping communities to help the military bases succeed in their mission and their focus. And so that's a huge piece. The other piece is, I think, Department of Energy has easier laws to work through with conveyances than Department of Defense. And Department of Defense goes through a much more complicated process. But the Department of Defense also gives money to communities to plan for this reuse, whereas the Department of Energy stopped doing that once again, I think in the early 2000s or even late 1990s. So those are just some of the things that I can think of.
Yeah, Seth, I'm going to make sure that everybody knows that when you say OEA, you mean the Office of Local Defense Community Cooperation. Our good Patrick O'Brien, who has been responsible in that office for a number of years, started working there 30 years ago, and quite frankly has done a great deal in terms of leadership. I completely agree with Seth that that's the kind of structure that you'd want to have in providing assistance to a local community, that technical assistance, which is always important. And that's a big difference. There's also some other, minor technical regulatory issues between the two departments. But what's interesting more than anything else is the changes really need to be made at EPA. The EPA often fails to recognize as cleanups occur that properties can be taken off of either a Superfund list or something else, which often impedes the ability of local communities to get conventional financing for their projects. And so the process in EPA should be addressed. It's much faster now in both DOD and Department of Energy. And if EPA could sort of recognize that, working with their federal partner to be able to enable a more expedited process in terms of taking off of the Superfund list or off of a contaminant list, that would be a helpful change.
Great. And the other question here, oh, sorry, David, go ahead.
Yeah, I was just going to say, and I can't really speak to DOD. I'm not really familiar with different projects within that agency, but I think I'd just like to kind of echo and reemphasize the idea of having a entity within the Department of Energy that could sort of work across the silos. Yeah, as those of us who are fairly familiar with the Department of Energy know, it's a very, very sort of compartmentalized organization. And I feel like there might be any number of opportunities for, if there was an office like Seth described that could kind of work above or kind of with a different focus than any of those individual program offices within the department. I mean, there's community engagement folks within, I think, most, if not all of the program offices, but sometimes it can be very difficult to connect the dots between where there might be a opportunity that the Office of Nuclear Energy is working on that might be a good fit for an NNSA or an EM site or something like that. And so to take that kind of broader perspective, I think would be very beneficial.
Great. And then, yes, we got about 11 minutes left here. So I'd like to, this last question here we have was, I think Michael had some comments earlier on legal challenges around revitalization. And then I'd like to leave about 10 minutes so each of you can have roughly 3 minutes for kind of closing remarks. I say that tongue in cheek as we planned for about 5 minutes for the introductory. We ran well over that. So we'll do our best to land the plane on time. So, so Michael, the question was around legal challenges as part of revitalization. Can you share a little bit about how those were resolved?
Sure. And again, I'll say when I talk about legal issues and sometimes how do you resolve those issues, I communicated earlier that it's all about communication. But I believe that the deed language is the first place where you run into legal issues because deed language often is very restrictive when it's being transferred, especially if there's an attempt to get property transferred early. And oftentimes the best resolution for that restrictive language is to negotiate a covenant restricting the use so that you can enable that to be used. Another legal area is regulatory compliance. That's something that we've had a few issues over time because there are often state, local, and federal regulations that conflict with each other. Oftentimes states, the regulators will say, you know, I'm not sure the federal government is fully interested in what our state interests are, and often have a higher standard. And federal agencies are not allowed to maybe do a cleanup beyond the federal standard. That often creates a legal challenge and delay that impacts revitalization. Those are usually resolved by local communities talking with both regulatory agencies and fitting a way to resolve that. Another legal area I mentioned was lawsuits. Sometimes, and like most judges, I don't think you just eliminate the ability of people to do lawsuits. We have to have a legal system that is a watchdog because it's often been very beneficial to communities' interests. However, when you have a legal challenge and someone legally and legitimately is making an effort to try to for the safety of a local community, you can use mediation, you can use other means to be able to have that legal effort not wind up creating a barrier to jobs, to economic recovery, to creating a cultural reuse of an area. And then sometimes you're going to wind up in litigation, and when that happens, it's an expensive proposition and you just have to live with it. But I do everything you can not to get there because there are never two winners in a legal solution. There usually is someone who thinks they've won, but they beat other people down to where the community loses in the end. So I'm very concerned about all of those. So those are the things I would say about legal resolution. We had several that were resolved by court order early on, and it was between local community folks who didn't trust the federal agencies to do the cleanup, and those were resolved in court. When it came to lawsuits that we engaged, we negotiated, we used mediation, we used replacements, we used public engagement, we used educational processes, and while it didn't always work, 75% of our legal challenges we resolved otherwise, other than in court.
Thank you, Michael. All right, gentlemen, about 7 minutes left. And so I'd like to go around the horn real quick with just kind of some parting remarks. Covered a lot of ground, a lot of great experience. And yeah, it's once again humbling to think of the experience that we were able to bring to this panel as part of the summit. So again, thank you all for being here. So to close things out, I'll go in reverse order. So start with David, closing thoughts.
And maybe in the interest of time, I'll keep mine pretty short, but I think this is an important conversation. And I recognize that there's a pretty broad audience from across the United States and across the world. And I think as we think about community engagement and revitalization, one of the things that I know we've really tried to focus on are, what are our core strengths and how can we leverage the cleanup effort to support economic growth, diversification, and then how do we play an active supportive role in moving the cleanup forward so we can kind of move on to the next step as a community. I think there's been a lot of evolution. I mentioned earlier that the community has grown substantially in the last 20 or so years. I think there's been kind of an idea that cleanup isn't going to be over soon. And there's been two competing ideas, I guess. One, that cleanup will be over soon and we got to figure out what to do next. And then there's another perception that maybe others have had, that the community just wants this cleanup to drag on for forever as a jobs project. And I think it's really neither of the two. We do as a community want cleanup to be completed as soon as possible, as well as possible, so we can transition in a very thoughtful way to what's next. And we feel like, with our capabilities and as we look toward the future of the needs of the country and of the world, that we can be a big part of assisting in kind of preparing for that future if we take the steps now in partnership with the rest of the folks in our community, as well as with the Department of Energy, with the contractors, with the National Laboratory, and everybody else in our community. And so having that kind of thoughtful and intentional approach to all of this is, I think, just especially critical. And with that, I just, again, appreciate the opportunity to be a part of this conversation.
Thank you, David. Seth.
Yeah, so vision is really the most critical piece. Your former Congressman Doc Hastings, used to basically tell everybody, make sure you tell a story that people can understand, and make sure the end of that story is within within a short enough period of time so they can see that getting done, within the time that they're in their job in the federal government or in Congress. So that's a critical piece. Michael's, the whole time, if I were to say one thing that he keeps saying, which is make sure you bring everybody into the tent to make decisions, bring everybody along together. Dave Replag said it also, speak with one voice. All of those things are critical. The other piece is know and understand what the law and the processes are. And if you don't like them, change them. They can always be changed. I always like to tell everybody the story about how I was yelled at by a former manager at the Hanford site, who basically told us that, you can never transfer land. No one's ever going to be safe. And the laws that you're trying to pass, ECA, to make that happen are a bad idea. He was obviously wrong. There's a lot of land that's been conveyed all across the country that's been reused, and that can get into beneficial reuse. But if we just accepted what he said at the time, all the communities, nothing would have ever happened. So I always like to say, as a lawyer, no is the beginning of a conversation.
Excellent. Thank you, Seth. All right, Michael, bring us home.
Hey, listen, as a disciple of Martin Luther King and John Lewis and the many others, and coming out of the 1960s and 70s as an advocate for civil rights, I want to recognize that that's an important part of what we're doing. And I want to make that part of this message, because the topic here is revitalization. Anytime you're revitalizing, you're talking about a metamorphosis. And when there's change, people fear change, regardless of whether it's good or bad. Recognizing that emotion in people is so important to a successful revitalization, because you can abrogate some of that fear by addressing it with education and by communication and getting rid of acronyms and talking to people in the way they communicate. And I think it's important that we have revitalization efforts that respect that you are dealing with a social change, you're dealing with an economic change, you're dealing with a physical change, you're dealing with changes to make areas safe, but more importantly, all of that's going to mean a cultural change that has to be enabled with true vision and true participation. So I think this is the message today. If you keep that focus and that attention that Seth and David talked about, and keep the message online, then you do have a dream.
Well said. Well said. All right, gentlemen, as I kind of mentioned before, incredible talks, incredible wisdom brought into this panel, and it's been a humbling to be part of. Thank you so much for joining us. And I appreciate you all being available as well with your contact information to continue this conversation, because I think the attendees, there's a lot more to be discussed, and sharing of knowledge and case studies and what's worked and what hasn't. And I think this, that's really at the heart of the RemPlex Summit is to be in these conversations and to develop these networks. So this has been great. Thank you all so much. And I believe
Thank you, David, for leading us.
and I think we're headed into break time now. So
thanks, Kevin.
Everybody, yeah, you bet, folks. Thank you all. So use the next 15 minutes, I believe, to grab a cup of coffee. And my challenge to you all is don't check email. Send a text to your significant other or your kiddos and tell them you love them, or pet your dog, or go outside and stretch. But better than checking email. The email can wait. So up next is up next our technical session, and I believe 10:45 start Pacific time. Nick or Karen, anything else we want to cover before we sign off?
No, thank you very much, Kevin, for an outstanding panel, and thank you to David and Michael and Seth. It was really an outstanding panel. I enjoyed every bit of it. It's like we are now at 10:30, so we are starting the break. The next one scheduled at 10:45 a.m. Pacific Standard Time is a technical session on multi-scale modeling and upscaling. It's a pretty interesting technical session, so I would love to see you all back then in 15 minutes. Thanks again, Kevin, for an outstanding job moderating, and Mark Triplett as well for organizing it, and Karen Smith for doing a fantastic job bringing this panel together. I will see you in 14 minutes now. Thanks again.
Thank you.
Good morning, Nick and Karen. Are you there?
Good morning, team. How are you guys?
So I think we're going to go ahead and get started. Welcome to the technical session on multi-scale modeling and upscaling. My name is Tim Scheibe. I am a scientist at the Pacific Northwest National Lab, and Fred Day Lewis, also at PNNL, is co-moderating this session with me. And we are really looking forward to the presentations that we have this morning. We're going to run through a set of 7 flash presentations, recalling that the full 15-minute presentations that were pre-recorded are also available on the website. So we'd like to make sure that you are aware that you can get more information and more detail there if you haven't already seen those. And then after the presentations, we're going to hold the questions for the speakers to the after all presentations have been given, and then Fred and I will moderate those questions. So if you have questions for the speakers, please put them into the chat as they are presenting, and we'll keep track of those questions and make sure that they get asked. towards the end of this session, the session is an hour and a half total. And toward the end of the session, we've reserved a half hour or more for a panel discussion in which we'll discuss some general questions pertaining to the topic of multi-scale modeling and upscaling. So with that, I would like to go ahead and get started. And our first speaker is Eleanor Fadley, who is from, she is a PhD student at the University of California, Davis. Eleanor, please go ahead.
All right, can everybody hear me okay? Excellent. All right, hello everyone. My name is Eleanor Fadley. Like Tim said, I am a second-year PhD student at the University of California, Davis, and I'll be presenting today on my research, the hydrodynamic and biogeochemical controls on manganese biomineralization in granular media. Manganese biomineralization is an environmental process by which microorganisms enzymatically catalyze the oxidation of aqueous manganese 2+ to solid phase manganese 3+ and manganese 4+. These solids are called manganese oxides, and they are reactive nanoparticles that have many applications for contaminant remediation. Biogenic manganese oxides specifically have been used in the literature at Superfund sites and to treat sites where there's mining-derived contamination. However, manganese oxides produced by microorganisms have not yet been used in the subsurface or at the pore scale to do in situ bioremediation. So this project is looking at how manganese biomineralization can be applied in porous media, specifically targeting the challenges of in situ bioremediation, which include the timescales of reactant transport and the relative effects of advection and diffusion, as well as fluid mixing within a heterogeneous pore space and the reactant availability to microorganisms that are performing bioremediation. So our research question is, how can hydrodynamic conditions be tuned to optimize reactant delivery and maximize uniform manganese oxidation throughout a simulated porous medium? And to answer this question, we are working with microfluidic reactors, which are also known as soil-on-a-chip micromodel systems. They allow the visualization and quantification of pore scale processes at the scale of individual bacteria and bacterial mineral aggregates within a porous medium using both bright field and epifluorescence microscopy. For this study, we're using a fluorescent tagged strain of Pseudomonas putida GB1 as our representative manganese oxidizing soil bacteria. This figure shows a design of our microfluidic reactors. The pore network geometry is adapted from a paper by Wang et al. 2019 that uses tomography images of a Ottawa silica test sand to reproduce this two-dimensional structure. So the first step in our use of microfluidic reactors to investigate pore scale manganese biomineralization involves characterizing the flow field throughout the pore network. And to do this, we have been injecting a fluorescent tracer, a conservative fluorescent tracer dye through the pore network to determine local fluid velocities and reactant concentration gradients from the inlet of the reactor, which is on the left, to the outlet on the right. Once we have characterized the reactant flow field, we have been inoculating the reactors with our Pseudomonas putida GB1, which are fluorescently tagged with red fluorescence. So this top image shows the pore network full of our fluorescent bacteria, and the plot on the bottom is a one-dimensional signal of bacteria aggregate distribution throughout the reactor. And we're trying to make this distribution as uniform as possible in order to promote homogeneous biomineralization reactions. And once we have characterized the flow field and inoculated the reactors with bacteria, we are investigating the distribution and spatial extent of manganese oxidation within the reactor. So these top figures show the pore network containing these manganese oxide aggregates, which are the brown blobs. And then the plots at the bottom again show a one-dimensional signal of the manganese oxide aggregate distribution as a function of distance from the reactor inlet. We're currently working on developing image analysis procedures to further quantify what we have been exploring in the microfluidic reactors regarding the distribution of bacteria and manganese biominerals, as well as constraining the transport velocities and mixing dynamics within a complex pore network. We're also working on developing time-lapse experiments to further constrain our experimental system and to measure manganese biomineralization reaction kinetics within the pore network. And most importantly, we're hoping to eventually upscale this biogeochemical process to bioreactors or field tests at contaminated sites. So we're hoping to start testing the reactor system with synthetic groundwater or wastewater, as well as environmental samples from industry partners. In addition to this process, having the potential to directly immobilize manganese contaminants by forming solid phase manganese oxides, we're hoping that this can serve as a twofold treatment system to subsequently remove and transform other co-occurring contaminants of concern using adsorption or oxidation. And I'd like to acknowledge my funding source, the Center for Biomediated and Bio-Inspired Geotechnics, or CBBG, as well as my collaborators at UC Davis and my PIs, Veronica Morales and Jaskelyn Pena. Thank you.
Thank you very much, Eleanor, for the presentation. Very nice. We're going to move to the next presenter. And again, please, if you have questions for Eleanor or the other speakers, please put those into the chat and we will make sure to get to those questions at the end of the presentations. So our next speaker is Nancy Marino. She is a researcher at Lawrence Livermore National Laboratory. And I'm going to turn it over to her, but I'm going to share my screen and run the slides for her. Okay. So, okay, should look good.
All right, yeah, thanks, Tim. So hey everyone, my name is Nancy Marino. I'm at Lawrence Livermore National Lab and I'm working on projects funded by the DOE Biological and Environmental Research Program, specifically the biogeochemistry of interfaces, previously known as biogeochemistry of actinide scientific focus area. And one of the projects we're working on, we wanted to examine whether subsurface planktonic microbial communities could be used as a tool to track groundwater hydraulic connectivity and water quality. And we have a multidisciplinary team with hydrologists, geochemists, and microbiologists. Next slide, please. And so the main reason for looking into this is three overarching reasons. And the first of which is that there are significant concentrations of microbes in the subsurface, and we know that microbes impact subsurface biogeochemistry. The second of which is several studies have shown that microbes can move through the subsurface, such as that shown by the previous speaker, Eleanor, and several factors have been identified that impact the movement of microbes. And third, there are cost-efficient methods available now, and so the cost is not necessarily an issue, not so much as compared to like the time it takes to collect the samples and to analyze the data. Next slide, please. And so microbes can be used as a source of subsurface information, and in this 2020 paper, which was surprising to me to see this kind of quote in a 2020 paper, but this paper stated that the microbial community profile in indigenous reservoir fluids is potentially a highly informative, but still largely ignored source of data for reservoir engineers. Next slide, please. And so that brings us to our case study where we wanted to examine the Death Valley Regional Flow System, or the DVRFS. This system spans 100,000 squared kilometers, and we wanted to understand at this large scale, can microbes inform us about hydraulic connectivity and water quality? The DVRFS has 4 major groundwater basins, which I'm showing in the map there on the right, but we're mainly focusing on the upper 3 groundwater basins. Next slide, please. And so one of the main analyses for microbial community sequencing data is to do principal component analysis. And one kind of example of that is non-metric multidimensional scaling, or NMDS. And this essentially plots the microbial community sequencing data onto a 2D space. And in the figures here, each point represents a location that we sampled at. And the NMDS information also inputs the taxonomic information, so the identity of the microbes, as well as the presence absence as shown in plot A on the left-hand side, or the relative abundance as shown in plot B on the right-hand side. And overall, we saw that the microbial community varies by location, and we observed 4 overall groupings from the NMDS, which is shown in the map on the right-hand side. And this map represents the latest groundwater model for the system, which was published in 2020. And one of the authors of this groundwater model is actually a co-author on our presentation here today. And the major outlier for the microbial community sequencing data here compared to the groundwater models is the Paiute Mesa Oasis Valley flow path, where the microbial communities of those 2 locations are actually not similar at all. Next slide, please. We also did network analysis of the common microbes. So these common microbes, we only included the microbes that were observed in more than 2 locations and have low coefficient of variation. And we also observed similar results as the NMDS, where the microbial communities vary by location. And on the groundwater map there, now I'm showing our kind of interpretation of the microbial community sequencing data and how microbes could be dispersed from recharge to discharge zones. Next slide, please. And so finally, I want to get to the question of why is the Oasis Valley microbial community so different? And we thought of 2 hypotheses, one of which is that the Oasis Valley microbial community is isolated. And so there could be biogeologic barriers that prevent the dispersal of microbes from Paiute Mesa to Oasis Valley. There could also be just really slow water flow from Paiute Mesa to Oasis Valley, or the infiltration of surface microbes or microbes from soil. The second hypothesis we thought about was that the Oasis Valley microbial community could actually represent an unperturbed or pristine community in this groundwater basin. So for the Paiute Mesa microbial community, these communities have been perturbed by underground nuclear tests. And so over time, they've been reassembled and adapted to their new environment. And the microbes from Paiute Mesa just haven't been able to be dispersed to Oasis Valley yet, and we can't pick up that signature. Finally, it could be an artifact of the study where we have a lot of samples that we collected from Paiute Mesa, but only 2 samples from Oasis Valley. And we don't really have any samples along the flow path. So it'd be great to do another study collecting more samples along the flow path to understand more about the microbial communities of this groundwater basin. Next slide, please.
That's about 6 minutes.
Okay, yeah, in conclusion, we have to combine bio into hydrobiogeochemical data to comprehensively understand groundwater systems. And there's a lot more microbial data that we can input into reactive transport models for further optimization and understanding of groundwater systems. All right, that's it. Thank you.
Excellent. Thank you very much, Nancy, for the very nice presentation. Again, please save your questions, put them in the chat. We'll have further discussion on these presentations at the end. Our next speaker is Bozo Vazic, who is a postdoctoral associate at the University of Utah. And I'm going to try to bring up his presentation quickly. Okay. Full screen. Whoops. Oh, come on. Okay, there we go.
Excellent. Okay. So, hello everyone. My name is Bozo, and I'm a postdoc at University of Utah. And basically, this presentation is going to be completely left field compared to what everybody else is going to present here, because the idea here was to see the influence of basically pore morphology, but also we include inclusions in there on mechanical properties using a higher order homogenization approach. So basically, we are not only looking at stiffness matrix and standard material properties such as Young's modulus or Poisson's ratio, but we're also checking out what's going on once we use the high order theorems, where basically we are introducing the strain gradient effects into our calculation. So next slide, please. Yeah, excellent. So basically, in our approach, what we did, we used to solve our homogenization problem, basically our upscaling, we used an open source Phoenix solver, which is an open source PD solver coming from I think University of Oslo. And basically, here is the flow chart of how we approach the problem. Basically, the geometry and the mesh are created outside of Phoenix because Phoenix doesn't have the best possibilities for that. So it's created in Salom. And then basically what you do is you plug in the meshes coming from Salom, you assign material properties, you define standard periodic boundary conditions, and then set solver parameters. We mostly use Kirill solver parameters for our solutions. And then what you do is we basically compute the upscaled value of stiffness matrix. And then we solve and compute the upscale values of the G and the D tensors, where G is the fifth order tensor, it's called the coupling tensor, and the D is the strain gradient tensor. Basically, that one is bringing in the strain gradient into the deformation energy. And that's basically a short version of how it's done. So next slide, please. The problems we were trying to solve is basically we have two sets of problems. One set is basically purely porous model, where we are changing the porosity from 0 to 50%. And the next set of problems is we are keeping the volume fraction at 20%, but we are changing the material properties of inclusion from basically purely porous case, where there is nothing, to basically a homogeneous material, and trying to see what's going to happen there. All of those examples are solved on different sizes of the RV, the representative volume element. We change the inclusion or pore shape between different circle, triangle, ellipse, square. And also we change the distribution. So we have a single RV with a single inclusion pore, and then we have uniform and random distributions. So next slide, please. So here, so this is basically our first problem set, where we are keeping it's a porous problem. So basically here we are changing the porosity and analyzing basically the first order parameters, mostly the stiffness matrix. And here we are showing the Young's modulus. And what you can see here is that pore shape has a huge influence on the value of Young's modulus. So for example, you can see that for circular and square shapes, which are symmetric, they're mostly similar, but elliptical pore is going to have completely different influence on the Young's modulus, and also triangular pore. Furthermore, pore shape doesn't only influence the value of the Young's modulus, it also influences the behavior of the material. So for symmetrical shapes like circle and square, you're going to have a cubic material behavior, and for elliptical shape, elliptical pore, you're going to have orthotropic material behavior. Next slide, please. So here, this is our second set of problems, where we are keeping the volume fraction at the constant value, but we are changing the material properties of the inclusion. And as you can see here, once the Young's modulus of inclusion is around 50% of the Young's modulus of the matrix, you can start seeing the influence of the pore shape, or in this case, the inclusion shape, on the material properties. So it also influences the Young's modulus and also influences the material behavior. And of course, the biggest influence is once inclusion basically becomes a pore. So next slide, please. So here, so those two first slides were basically first order parameters, the stiffness matrix. We are here going to check what's going on with, so this is the most interesting cases with our second order parameters, meaning basically our D matrix, the strain gradient tensor. And so you can see here is what we are doing here. We have a change of porosity between 0 and 70%. This is a porous case, so there is a pore in here. We couldn't go before about 70% because at that point we are disturbing the periodic boundary conditions. And we can see here at certain porosities, we are going to have a maximum influence of the D parameters, meaning we're going to have the maximum influence of the higher the parameters on the deformation energy, which means that we are able to use this kind of approach to model different metamaterials and tailor them to specific purposes. Next slide, please. And this is even okay. This is even a better case. So here we have a square pore, and you can see here that as porosity is going to the theoretical 100%, we are having the C matrix, the stiffness matrix is going to 0, which is normal behavior of the stiffness matrix, but the D values are started to exponentially grow. And this is something that is shown in pantographic metamaterials, where basically all deformation is controlled by the higher order parameters, the strain gradient parameter of deformation energy. So this is one of the other interesting examples. Next slide, please. And so basically, in conclusion, what we can say is the TX modulus and material behavior are strongly influenced by the shape and the material properties of inclusion. And also, I forgot to mention in my previous slides, we also checked the distribution, and distribution has almost no to little influence on the stiffness matrix, but it has a huge influence on the D parameters and G parameters, which is normal. And also, basically, by utilizing this kind of sensitivity of the stiffness matrix and the high order parameters influenced by the microscale morphology, we are basically able to design metamaterials for very specific engineering purposes, especially now with the development of the 3D printing and other additive manufacturing methods. Next slide. So basically, thank you for your attention. And I was just going to say that our future work is basically plugging in the thermal part and having a fully coupled thermomechanical model for this approach. Thank you.
Unmute myself. Thank you, Bozo, for the presentation. Very, very much appreciated. And I see some questions starting to come in the chat. Again, remind people to, if you have questions for the presenters, please put them in the chat, and we'll be asking those after the end of all the presentations. Our next presentation is going to be given by Fred Day-Lewis, and Fred is a scientist here at Pacific Northwest National Laboratory and co-moderator of the session. And I'm trying to get the presentation up while I'm talking. So multitasking isn't my greatest skill. Okay, I think you might see it there and should be in presentation mode. Go ahead, Fred.
Thanks, Tim. I'll begin by mentioning my co-authors on this. Today, I'll be reviewing work done over the last 10, 15 years on this problem. So my co-authors include Marty Briggs of the USGS, Kamini Singha of Colorado School of Mines, Lee Slater at Rutgers University, Newark. There are many other people acknowledged in the full talk, which I hope to see available online today. I looked earlier and I noticed that it wasn't there, but was assured that it would show up and be available for you to view in its entirety. The title of my talk is Geophysical Approaches to Understand Immobile Porosity, Review and Recent Advances. Please advance the slide, Tim. So in the full talk, I go over immobile porosity, its definition, why it's important, electrical geophysical monitoring approaches to this problem, which will be the focus of this lightning talk, and then several examples spanning lab to field scale, including use of other types of data, including nuclear magnetic resonance and spectral induced polarization to help understand immobile porosity. I'll briefly cover pore network modeling and its use in this work, and then wrap up with mention of some ongoing work and future directions. Next slide, please. Thanks. So immobile porosity, or sometimes called less mobile porosity, comprises the matrix porosity and dead-end fractures, as well as just low permeability zones in unconsolidated heterogeneous aquifers. We also see evidence of immobile porosity in stream beds and lake beds, often referred to as microzones, where anoxic conditions can occur, even in bulkoxic stream beds. Immobile porosity is very difficult to characterize. This is because it's largely invisible to classical methods of interrogation. The reason that this is in the multi-scale modeling session is because this is a multi-scale problem. A mobile porosity occurs over a range of scales and is sometimes referred to as multi-scale mass transfer. Estimation of the parameters controlling the exchange of solute, usually contaminants, between mobile and immobile porosity focuses on history matching rather than in situ direct measurements, and that motivates the use of geophysics for this problem. Tim, could you just click once, please? And in the presence of immobile porosity, we divide the representative elementary volume of the pore space into two overlapping continua. The first is the mobile domain pictured here, and please click again. And the second is the less mobile or immobile domain. And in the presence of immobile porosity, we have, instead of one transport equation, two, one governing the movement of solute by advection and dispersion in the mobile domain, and a second equation governing the exchange back and forth between the mobile and immobile domain. Now, there are extensions to this model for multi-rate mass transfer with many different immobile compartments and exchange rates, but this is the simplest form here. Next slide. Now, the mobile domain is what we sample when we sample conventionally. Oh, thanks, Tim. You can move on to the next slide, though. But we have techniques that can interrogate the immobile domain indirectly, and these include geophysical methods, as shown here. We've used these at different scales. You can click just once. To look at the laboratory, the stream bed, and the field scale. And in these experiments, we look at the non-equilibrium between mobile and immobile porosity using electrical methods, which are sensitive to the total pore space rather than just the mobile. And in the presence of this non-equilibrium, we end up with a nonlinear relation between bulk and fluid conductivity shown at the bottom of the page. And that can give us information about immobile porosity and its controlling parameters. Next slide. This data can be analyzed using history matching in the context of numerical models or by simple graphical means, as you see on some of these plots, which are explained further in the full talk. The basic takeaway here is that using analytical, semi-analytical, and numerical approaches, we can back out the ratio of immobile to mobile porosity and the exchange rate governing diffusion between the two compartments. Click once, please. And then in the upper left, we also have pore network modeling to help look at the fundamental signature, electrical signature of immobile porosity, and understand what information we can gain from the combination of geophysics with conventional sampling. Next slide. Thanks very much. And I'll be happy to answer questions at the end of the session.
Great, thank you very much, Fred. Our next speaker, and I've got the slides in the same deck, so I'm just going to continue presenting. Our next speaker is Glenn Hammond, who's a researcher at Pacific Northwest National Laboratory. Glenn, please go ahead.
So my name is Glenn Hammond, and I'm a computational geohydrologist at PNNL. I spend most of my time developing simulation tools, in particular reactive transport codes. So I'm going to talk a little bit about how we can use reduced order modeling in geochemistry, simplified geochemical models, to speed up our run times in these simulators. Next slide, please. So the question here is, how can we take a fully complex geochemical model, in this case, it's going to be uranium surface complexation, and how can we maximize our speed up by using a simplified chemical approach? Next slide, please. So several years ago, Peter Lichtner and I performed modeling at the Hanford 300 area, and we were looking at uranium surface complexation at the site. And at the site, river water intrudes, picks up uranium, it pulls it back out to the river. And so I use this as basically an idealized conceptual model to compare the performance of an alternate approach. On the right-hand side, you see my conceptual model, you see the flow regime, we have this clockwise flow pattern. It's ultra simplistic, but it does the job. The plume is in red, you can see the path that the plume travels. River water will come into the site and it will pull uranium back out. Next slide, please. So this is the full geochemistry for this problem. We have 15 primary aqueous species 88 secondary aqueous complexes, and you can see those two dominant urinal complexes there. Those are aqueous. We have a mineral, and we have two surface complexes in this problem, surface complexation problem. Next slide, please. When we look at the river water and the groundwater composition, and this, what you see here in the table, is the simulated river water and groundwater composition, we see some differences. We have a slightly higher pH in the river, much lower ionic strength in the river, and our major cation and anion concentrations are significantly lower in that river water. If you look toward the bottom, we have this KD star. That's a dimensionless KD. Basically, it's the ratio of the sorbed versus aqueous uranium at the site. For river water, when river water is present, our dimensionless KD is 62. And when groundwater is present, it's only 5. So how can we use this information right here to develop a more simplified model for modeling uranium transport at the site? And that's on the next slide, please. So I took my full geochemical model and I evaluated the KD using different ratios of river water and groundwater. On the plot on the right-hand side, you can see the fraction of river water between 0 and 1. So when there's no river water, the KD is 5. When it's completely river water on the right-hand side, it's 62. And then I use different ratios, different mixing ratios of those two waters. And you can see there's this nonlinear relationship between the KD and that fraction. I then went to a linear KD model and said, how can we take this simplified model and how can we use it in a nonlinear relationship to replicate what the surface complexation model does? And that linear relationships there shown there at the upper left-hand side, where you calculate the sorbed concentration from the KD and the aqueous concentration. So what I did is I took the end-member KDs, 5 versus 62, and I took the difference between them and multiplied them by a river tracer concentration. So when the tracer concentration is 0, it's all groundwater. When the tracer concentration is 1, it's all river water. I then fit this equation, raising that tracer concentration to a power. In the case of this analysis here, the fit parameter was 3.26 for the power. Using this equation, I then executed the same reactive transport code, but using a simpler reaction. We call it network, but the simpler reaction for surface complexation. Next slide, please. Here we see simulation results at just over 5 years. You can see that the dynamic KD actually matches the equilibrium surface complexation quite well, both the shape for the sorbed and the aqueous plumes, much better than the constant KD or a multi-rate surface complexation approach. Next slide, please. And these are the performance results. Now, I did a comparison using operator splitting versus global implicit. With operator splitting, we split transport from reaction in our solution process. Global implicit, we solve them simultaneously. And then I ran these analyses in a specified uniform flow field and also a heterogeneous flow field. And we see that for a uniform flow field, regardless of which reactive transport formulation we use, we pretty much get a speed up of around 20, whereas when we use heterogeneous flow, it's more on the order of 10. Now, if you ask me whether this is a useful speed up, I think it's valuable. I do think that high performance computing can take us a lot further. And in my full presentation, there are some more results that show the impacts of high performance computing versus a simplified conception model or simplified reactive transport model in this case. And that is my presentation. Thank you. Next slide.
Thank you, Glenn. Appreciate that presentation. We are moving on next to Mark Rockhold, who is also a researcher at Pacific Northwest National Laboratory. Mark, please go ahead.
Hello, everyone. Yeah, can you guys hear me? Okay. So the focus of this talk is on the use of multiple data types for generating alternative conceptual models of the subsurface. So one type of feature of particular interest to us is at Hanford is paleo channels. So this talk will focus mostly on the development of models that include paleo channel features. I will mention there were some really great talks yesterday about work being performed at Hanford and including a discussion of various modeling efforts. And then the subsequent session on geophysics touched on, the use of geophysics for characterization and monitoring. So both of those sessions are relevant to this talk. So I encourage you guys to look at some of those presentations. So I'd like to acknowledge Richland Operations Office of the U.S. Department of Energy and PNNL's Deep Vadozone program for supporting this work. Next slide, please. So there's some challenges that we have at Hanford that are not unique to Hanford, but I've listed some of them here. It's a very large site with a very thick vadozone, and we have relatively sparse characterization data, multiscale heterogeneities also. So the lower photo is interesting. It shows these giant ripple marks in the face of a pit that was excavated at Hanford for burial of decommissioned nuclear reactors. So the C and the T in this image indicate the crest and trough of these giant ripple marks. So the interface, I'd like to draw your attention to the interface that defines these features. And this would be really difficult to pick up using conventional core sampling from boreholes and wells. The upper photo shows an excavation showing millimeter scale laminations and cross bedding together with cobble and gravel sized material in the same very small region. So, the small orange boxes, illustrate the, type of sediment you might collect in different locations within this small area. And the large orange box represents the size that you might have for a vadozone model grid block. So together, these photographs illustrate some of the potential disparities of scale that we have between actual subsurface features, site characterization data, and modeling. Next slide, please. So we have multiple lines of evidence for paleochannels, some of which are listed here. The slide at the figure at the upper right shows the iodine 129 plume in 2018. And the dashed black line in this image shows a possible paleochannel through which the plume has been transported. The red lines on that figure show the approximate locations of ERT surveys that were done recently. And then the results of those surveys are shown in the images at the bottom right of this slide. So you'll note that the dark blue regions in these ERT transect images sort of look like cross sections through channel features. So the image, and I should note that Judy Robinson also has a presentation posted on these measurements, and she gave her talk yesterday. So the image on the lower left is the LiDAR-based elevation data, and you can see sort of outlines of these relic paleochannel features in the LiDAR data. So we'll be using all of these data to try to generate some alternative models. Next slide, please. Okay, we would like to be able to utilize as much relevant site characterization data as possible to inform the development of alternative models. And the approach we've adopted is multi-point geostatistics. And there's a fairly rich literature on multi-point geostatistics with some key names here. So it differs from traditional two-point variogram or correlation-based models in that it relies on the use of training images to define the scale, shapes, and connectivity of features of interest. So we've, again, used the LiDAR data to develop training images. And so you can also use outcrop photos and other types of data, but the LiDAR data were convenient for us in this case. And we're also using grain size distribution data to define sediment classes and using those as hard data, and ERT data as soft data. So MPS is a pixel-based method or voxel-based method, so it can easily accommodate the use of hard measured data at their measurement locations as well as soft data. Next slide, please. So we're generating three-dimensional conditional simulations to produce alternative conceptual models, and a horizontal slice of one of those is shown in the top figure here. And the alternative models use a base or reference model, but include an additional sediment class that represents these paleochannel features. These features are allowed to cross-cut some of the other hydrostratigraphic units in the base model. And again, the alternative models are conditioned on both grain size and the ERT data. So the base or reference model is a calibrated mod flow model of the site that's referred to as the P2R model. And there were some talks yesterday that discussed the use of this model. Next slide, please. So we've identified an approach, multi-point geostatistics, that we can use to evaluate some uncertainties associated with paleochannel features. And we're using the LiDAR data to generate training images and grain size data and ERT data as hard and soft data to condition these fields that we generate. So MPS is also amenable to the use of other types of data, including seismic data. So we may explore that in the future. So this approach supports the evaluation of the impacts of uncertainty associated with paleochannels, which may have higher hydraulic conductivity and thus affect, solute transport and dilution and, transport to the Columbia River. So the methodology described here is being used for scoping studies to assess the potential impacts of paleochannels on flow and transport. Next slide. So in summary, thank you very much for your attention. Here. That's it.
Thank you, Mark, for the presentation. And at this point, we're down to the last presentation, which is my presentation. So my name is Tim Scheibe. I am a research scientist at the Pacific Northwest National Laboratory. And I would like to talk a little bit about something we call the Community Data Model Integration Infrastructure, or CDMI. For those of you who like to play Wii games, you know what a me is, a character on the Wii game. So I made a little me for myself, but help you remember the acronym. This is kind of a different talk. So this is, I think, what we've seen so far is presentations starting from some processes involving, very microscopic geochemical processes like manganese oxidation and microbes in groundwater systems, the effects of pore scale geometry on mechanical properties, and then sort of moved up to larger scales, looking at geophysical interrogations, flow and transport, and reaction models. And I think what I'd like to present today on this last one is kind of a framework for looking at multi-scale problems like these within a high-performance computing environment at a national scientific user facility. And so what I'd like to start with is introducing those of you who may not be aware of it to EMSL, the Environmental Molecular Sciences Laboratory. So EMSL is a scientific user facility operated by the Pacific Northwest National Laboratory for the U.S. Department of Energy, and it is located at PNNL in Richland, Washington. As you might imagine from the name, it's focused on molecular sciences. So that means there's a lot of instruments here at EMSL that do high-resolution molecular characterization of environmental and biological materials, including things like mass spectrometers, microscopes of various types and intensities, NMR, and many other types of instruments. Oh, that wasn't supposed to show up yet. I think it's on a timer. But I guess it has good timing because that's one of the instruments. It's an FTICR mass spectrometer. It does high resolution characterization of the mass of the types of materials that you put in, of the samples. And in our case, we're using it intensively to characterize the composition of organic matter in natural environmental samples. So if you take a sample from a river or from an aquifer, you can characterize the organic matter in that by high resolution mass spectrometry, which tells you that for all the different types of organic matter compounds, gives you their mass with high enough specificity that you can actually determine their composition in terms of their key elements. Now imagine that if we had that information and we knew how to incorporate that into a model of carbon cycling, that we could automatically, when a sample was processed on this machine, we could automatically run a series of scripts that would generate parameters from those data for a model like the microbially explicit carbon cycling model shown schematically in the center here. These are models like the MEND model or the MIMICS model that you may be familiar with. And these can be executed on EMSL's supercomputer cluster, which is called Tahoma. Now, further imagine that the outputs from those microbially explicit models could be used to generate then parameters for a larger scale land model, such as the E3SM land model or ELM, which is part of the DOE's climate modeling system at the global scale. And it considers microbial processes implicitly, but not explicitly. And by coupling these two, then we could potentially increase the fidelity of the larger scale model to small scale microbial processes informed by molecular characterizations. And then further imagine that that approach could be extended to a full ecosystem of computer simulation codes that are used to represent a variety of flow, transport, and reaction processes in a variety of environmental settings or ecosystems. And that is really what is being currently developed by, or has been developed by, the Ideas Watersheds project. And so this is the ecosystem of that project shown here. This really underlies the overall vision of this project, which is to enable multi-scale modeling and experiment data integration capabilities that are accessible to the science community through a scientific user facility. In other words, can we actually iterate across scales of data and models ranging from microbially relevant scales, genome characterization, up to pore scale models, plot scale models, and ultimately watershed scale models. And to do that, what we've done at the EMSL is start to put together an extensible framework for multi-scale data model integration. It's built around our data archive, which is now called Nexus. It used to be called MyEMSL. It's built on the Pacifica software platform, which provides mechanisms to ingest data from a variety of instruments across the EMSL laboratory, deliver that data through a downloader to users or to the computing system for use in models. And on top of that, we put something called a Clouds Event Agent. This is really where orchestration tools come in. Orchestration tools are software developed by cloud software systems to orchestrate the events that happen on a cloud system of computers. And we've applied that to a scientific workflow by allowing it to then, when a piece of data comes into the archive, either from a model output or from an instrument, the events agent sends out a notification. And you can program a web listener that will then apply certain directives to that. If you see a piece of data come in from the mass spectrometer, run these scripts to process it into model parameters for this model, and then execute that model. And so if we can develop specifications that allow those models to talk to one another and ingest those types of data, then these can be very useful for our users. And so what we're hoping to do is to make this available to the user community through EMSL's normal user access capabilities. EMSL has a proposal system that allows users to access the various capabilities of the user facility by a peer-reviewed proposal process. And so with that, I would like to thank everyone for your attention, and also thank again all of our speakers for the great presentations. And I'm going to stop sharing my screen, and we will start in on the question and answer session with the speakers. And I think the first set of questions is for Eleanor, and Fred is going to moderate that.
Great, thanks, Tim. Our first question for Eleanor came from Nancy. Nancy, would you like to ask the question yourself?
Sure. So for the microfluidics experiment, were you able to test like anaerobic conditions, or are you planning like in the future to do redox gradients? And then I have a second question. How much time did it take to have uniform distribution of the Pseudomonas in the microfluidic strip? And then how much time did it take to actually form the manganese oxides?
Okay, so those are really excellent questions. I'll address the first one first. The reactors that we are currently fabricating and working with are gas permeable polymers. So they are not anaerobic at this time, but we're working on developing gas impermeable reactors so we can really tightly control the dissolved oxygen concentration within the reactors, and potentially also test redox gradients, because manganese biomineralization is such a redox sensitive process. Your next question, how much time did it take to have a uniform distribution of Pseudomonas? That's a really interesting question. My research group works extensively with manganese biomineralization, but we've mostly been studying it in batch systems. And we know that in batch systems, the microbes have to reach stationary phase of growth before they start producing these manganese oxides. And that takes about 16 hours. So we're still working on constraining the amount of time it takes to grow and distribute within the microfluidics, since they're very different from a well-mixed batch system. But in that figure that I showed with the pore network where the bacteria are in red fluorescence, that was an image showing 16 hours of growth. So the bacteria were fed for 16 hours, and then we stop feeding them, let them reach stationary phase. And at that point, they begin to produce the manganese oxides. Did that answer your questions?
Yeah, cool. It's very cool work. Thanks.
Oh, thank you.
Great. Thanks. Tim, you also had a question in our document for Eleanor?
Yeah, I had a couple questions. So my first question is kind of similar, I guess, to Nancy's second question. And I'm just wondering, what challenges you experienced in trying to grow Pseudomonas in the microfluidics device. We've also done similar experiments at EMSL, and with Geobacter, we had a lot of trouble getting them to grow and to stick. I'm wondering if you experienced any problems or if that was relatively easy.
That's another good question. So this project is relatively new, and we're still working on sort of constraining and setting the parameters of our system. We are testing different flow rates. We're sort of trying to figure out right now what is the maximum flow rate that the bacteria can withstand before they get washed out of the reactor. You may have done some similar tests. And for our bacteria specifically, Pseudomonas don't start producing biofilms until they're in stationary phase. So while they're still growing, they have the ability to move around, and even those large aggregates are moving through the pore network. So we're working on that. It is challenging.
It is definitely challenging. And I guess this is my second question is maybe overly simple, and I apologize, but does the manganese oxidation reaction, which is biologically mediated, does it require any other nutrients besides the manganese and the oxygen for the microbial growth, like carbon or any other nutrients? And if so, did you provide those in these experiments?
Yeah, so for the bacteria growth, the bacteria, they need a suite of minimal salts as well as a carbon source, and they do need manganese to be present. And like I said, they're anaerobic bacteria, so we do need manganese, aqueous manganese 2+, they need oxygen, and then they need some trace minerals, trace nutrients, and a carbon source.
Okay, thank you. Fred, I see another question just came up in the chat from Mark to Eleanor.
Mark, would you like to ask that?
Yeah, Eleanor, I was just curious, in the work that I've done with microbes in the past, we've always had problems with contamination, by things that we didn't really want in the system. So did you have to do any kind of special sterilization protocols to get this to work?
That's a good question. So we work in a sterile environment when possible. I mean, we have general sterile bench techniques. The bacteria we're using, this fluorescent tagged strain, also has an antibiotic resistance. So it's not a wild type bacteria. So we're able to control contamination to a certain extent that way. But it is difficult once we start working in the reactors. It's hard to keep those sterile inside the chambers. There's a lot of tubing and syringes that are challenging to maintain sterility for sure.
Thank you.
Thanks. Tim, shall we move on?
Sure, I think that's all the questions we had for Eleanor. Nancy, I didn't see any questions in the chat for Nancy, but I had a question for you. So as you were presenting, I was thinking about the potential application of microbial assembly methods, and then you kind of preempted my question by mentioning that on your last slide. So obviously you're aware of them, and I'm wondering, have you tried those yet in terms of techniques that allow you to distinguish between assembly by dispersal mechanisms, stochastic and deterministic mechanisms? And if you haven't tried that, have you been in touch with James Stegan, whose work you mentioned, and in regard to that?
Yeah, so we did do ecological null models in our data analysis. So very nice question. I read like all of James Deegan's papers on that. So we did it. Those models did help us to decipher like between dispersal between the locations that are similar that we found in the NMDS and in the network analysis. So it helped to corroborate like what we already identified. So it's just like, it's kind of an additional layer of like, yes, this works. We did, and for example, with Oasis Valley, the ecological null models identified that it was like, it was essentially an isolated like system, not too much dispersal at all. And I think mostly it was like geochemical variation that was influencing the microbial community assembly, as well as stochastic processes. Yeah.
Okay, great. Very nice. Yeah, so let's see. Did anybody else have a question for Nancy? Any of the speakers? If not, we'll go ahead and move on. So Fred, do you want to ask the questions for Bozo?
Sure. Let's see. We have a few that Tim and I had compiled here. If there are any other questions for Bozo, please put them in the chat. First, how computationally intensive is the approach? What kind of resources do you need to run your simulations?
It's not that computationally expensive because we are just analyzing one RV, so one representative volume. I mean, also depends on the mesh density and what type of element are you using. Like the shape functions, linear, non-linear, cubic. It's going to affect your process. But basically, for our approach, it's not that computationally expensive. It's not a standard FE square approach where you're basically solving the whole system, downscaling at each Gaussian point, and then recalculating the displacements and stresses, and then upscaling those parameters back to the macro scale. What we are doing basically is we are solving this a priori. So you are going to get a priori, you're going to get the values of your stiffness matrix and your higher order parameters, and then you can later easily use them in the calculation itself. So also I need to mention this is time independent process. So if you have some kind of change of, if you have a huge deformations and then the pore morphology is changed, then of course you'll have to recalculate the RV.
Okay. And what about the effects of things like moisture or cementation, other realistic effects in the pore state?
We are currently working on the thermal, plugging in the thermal part, and then later on, hopefully, moisture and other chemical processes. So the problem here is, especially in the higher order homogenization, is we are starting from the generalized continuum. So it's not a standard. For example, in standard mechanical engineering, you're using linear elastic continuum. So everything is linear. You have the stiffness matrix, you get the Cauchy stress, and you're good to go and calculate basically whatever you want. But in our case, there is a generalized continuum theory coming out now, but there is almost none for coupled processes. So, for example, for linear thermal elasticity, you have the standard approach where you have the temperature tensor coming to the Cauchy stress and all that, but there are no generalized continuums for fully coupled thermomechanical processes. And especially once you go into the higher order parameters, all those huge tensors of 6th order, 5th order, you are exactly not sure what's going on in there because there are no experimental tests that they can confirm your parameters. Only thing we can do is we can load a structure, calculate, for example, deformation, and see if our approach with higher parameters are going to be more exact than a standard FEM in linear continuum. That's the only way we can test our hypothesis. It's going to be the same with thermal part, and then again, the same with if you include moisture in there or fluid flow or some kind of, let's say, two-phase flow or something like that. It's going to be, again, especially in higher order terms, it's hard to guess what's going on in there. The experimental community needs to catch up with the numerical one for us to have exact answers.
Great, thanks. We have a question in the chat from Mark. Mark, would you like to ask that?
Yeah, Bozo, one of your findings was that pore shapes have a strong influence on the elastic properties. So, unfortunately, pore shapes are kind of difficult to measure. So I'm just wondering about, if you've thought about alternative or combinations of experimental methods that might allow you to tease out elastic properties, related to pore shape and things.
Well, we are thinking about, so there is it's called the rock portal. They do have 3D scanned images of porous materials. So we are planning to use those as an exact representation of the RV and then start from there, where they already segmented the images. We know exactly what are the pores, what's the material. But in our case, our approach here is, so you have basically two approaches. You can either use some kind of same images or something like that coming from the experimental side, and then work on them, extract the pore morphology, and then plug them into our solver. But the other side, what is for us more interesting is it's basically 3D printing, where we are controlling the pore. So we are controlling the shape and the size of the pore. Mm-hmm. So this is where this approach has let's say a better, more viability, because you can then you can experiment, because you're the one controlling the pore shape, the pore density, how many, also the distribution, and then you can play around with different pore morphologies and see what's going on. But yeah, I agree. It's hard to, it's hard to incorporate real life data into these kind of numerical calculations. Yeah. Especially if you are crossing huge scales. From my mechanical point of view, we don't have this huge scale change, but in geological terms, you're going from 1 nanometer to 10 kilometers. That that scale changes. I'm not sure that without machine learning, you're going to be able to solve these kind of problems.
Yeah. Okay. Thank you.
Thanks.
Great. Let's see. Before we go on to Fred, questions for Fred, wanted to mention that the organizers are asking the people in the session who have viewed the presentations to vote for their favorite presentations from this session and the other sessions that we're having. And so I think Nick, or maybe Kelly or Blake or Karen will put a link in the chat that you can vote for the presentations. Karen, do you have, there we go. Okay, I just saw it come up, so. Karen, I think you're muted, maybe, or we're not hearing you anyway. Okay, I don't know. Anyway, hopefully you saw that.
And this is Nick. Just go down and there is a poll button that you can push at the end of the screen. So all attendees are if you folks wants to vote, you can just click there, and then a menu that is showing in the screen right now is presented to you, and then you can actually check or choose among the best presentations. Thank you.
Great, thank you, Nick, for clarifying that. So the poll there down at the bottom. And so we'll move on. We want to save some time for our panel questions, so we'll go through a few quick questions for the remaining speakers. Fred, Nancy had a question for you. Nancy, would you like to go ahead and ask that question?
Yeah, I found your talk really interesting to use the electrochemical techniques. And I was just wondering if you had any thoughts, or if there's any studies out there that have used geophysical assessments to decipher between abiotic and biotic contributions for the immobile pore spaces.
Well, we used the geophysical assessments to quantify immobile pore spaces in stream and lake beds where they are important for N2O production, it seems. but not really to discriminate between a mobile pore space that's abiotic or biotic. But it definitely, I think the technique has applicability to help quantify a mobile pore space across, different settings and scales. Thanks.
Thank you.
Okay, great. Thanks, Fred. Let's see. Let's move on to questions for Glenn. Fred, did you want to? Is there any questions for Glenn?
Yeah, Glenn. We had a question that Tim and I put together here. Is there any theoretical basis for the power law form for KD, or is that entirely no?
No, none whatsoever. It's just a bit. I just wanted to see how it would work.
Mm-hmm.
And it was because we've known about this the stronger sorption when the river water is present for years. And I actually had a conversation with T.P. Clement about 15 years ago about whether what I just did would work. And there's a workshop in Germany on reduced order modeling for geochemistry. And I thought, I'm going to give this a try and see how it pans out. And that's where I originally presented the results. I also included the impact of high performance computing too. So yeah.
Okay, great. Let's see. I got one question for Mark. Mark, so we were wondering, how did you actually do the conditioning on the multi-point geostatistics to the ERT, and specifically, how do you relate the paleo channel presence or absence to the electrical conductivity response?
So what we did is we basically sampled the ERT results, so we have a transect and we can sample along that transect to pull out individual values. And then we've binned those results, basically determine thresholds that we're basically saying this is, if you're above this threshold or below this threshold, you're in one category or another. And so those discrete points that we've binned and sampled, then we use as hard or soft data. And in the case of ERT, we use it as soft data. In the case of grain size distribution metrics, we use that as hard data.
Mm-hmm. Okay, great. Thanks, Mark. And the last one, I don't think there's any questions for me. Fred, did you have any questions that you're aware of?
Tim, this is going to segue into panel discussions, but I was curious in your talk and also coming out of the session yesterday from subsurface remote sensing about multi-scale characterization and how that can feed better into modeling. Like, where are the gaps that you see and how can we fill them? It seems like most of our characterization methods are aimed at one scale or one model, and how do we get all this to work together?
Right. Yeah, I think that does segue into some of the questions we wanted to have discussion with the panel. From my perspective, the approach we're taking, we're trying to make that as flexible as possible so that pieces can talk to one another in a sort of loosely coupled way, right? So then the idea is you could inject the data at the appropriate scale. We have scale-specific models that generally don't talk to each other. And then we have different scales of data, and often we have a mismatch between the scale of the data and the scale of the model we're trying to use. So if we can have those connections so that models can talk across scales, and then you can inject the data at the right scale model, whether it's the pore scale, the molecular scale, the field scale, then that might help overcome that. Of course, you still have a lot of practical barriers in that approach, but trying to make that system as flexible as possible to allow that.
Thanks.
So let's go ahead and move to our panel discussion. Let's see, I think we have about now 20 minutes left. Is that right, Nick? So we came up with 5 questions, and those have been shared a little bit ahead of time with some of the speakers. So hopefully they've had at least a little time to think about them. What I'd like to maybe start with is this question. So it ties into the question that Fred just asked. What new or novel approaches to characterizing or modeling multiscale heterogeneity and its impacts do you see as having the most potential for improving predictive power of models? And so it kind of gets to that data characterization, multiscale modeling effects. And so I'm wondering if any of our speaker panelists have any thoughts or comments on that question. And you can feel free to go ahead and just unmute and respond at will.
Yeah, Tim, if I could comment on this, I'm pretty excited about some of the work that's going on with, we've got a new infusion of geophysicists at the lab. And so we're starting to bring to bear, multiple geophysical modalities that we haven't really used very much in the past at Hanford, namely ERT and then some EM methods and also seismic. And I think there are some real opportunities for, even though those things generally measure multiple variables, when you sort of combine those multiple modalities, you can actually tease out specific, values of, say, water content or porosity, things like that. So I'm pretty excited about that. And of course, we need hard data, to tie things down. So this is a challenge in it's kind of I'm excited about the opportunities, but it's also a challenge because with ERT in particular, we have steel cased wells. So our control data, we can't sort of pair that up with the ERT data, right? Because, we have the interference effects. So we have to think through some of those challenges and come up with some solutions for that.
Yeah, thanks, Mark. I think in that context, there's also some challenging scale integration issues because the geophysical responses are going to depend on processes at different scales. So for example, in Fred's talk, he talked about, secondary porosity, and that could be a very small scale feature or relatively large scale features. Hard to know how to interpret that, I'm sure, at times, or certainly if you have microbial responses versus sort of large scale flow responses or gravimetric responses, those could be all at different scales. So yeah, that's interesting. Any other thought?
This was probably mentioned yesterday, but then what I really like about the geophysics is the three-dimensional characterization, because most of what we have now is it's point data, right? And it's sparse.
Mm-hmm.
And so that's, if we couple that with the flow model, with the transport model and geophysics, you invert for that, then it's just that three-dimensional piece of data that you can invert against.
Mm-hmm.
I meant to ask this earlier. Fred, have you ever looked at the multi-continuum?
Yeah, the multiple interacting continua.
Yeah. And what would be interesting is because the biggest issue, I submitted a proposal 15 years ago for multi-continuum, and the biggest issue is how do you parameterize it, right? It's just daunting. But can the geophysics be used to tease that out, those parameters?
That's so in the context of a different model, the multi-rate mass transfer model, where the different continua only interact, the different immobile continua only interact with a mobile domain. We've worked on that. In the MINC model, they all interact, or rather, each immobile domain interacts with the adjacent immobile domain. So the parameterization for that gets harder for sure. But I think there is promise there. I mean, we can talk about that offline and all day sometime. I'm very excited about electrical geophysics, not just the DC resistivity that I spoke to in the lightning talk and in the full talk, but spectral induced polarization for that problem. I think there's real potential there. And just in response to this general question, I also, I advocate for geophysics all the time as a suite of strategies that we can use to tackle multi-scale characterization. But I think increasingly, like Mark said, we have technologies that do dovetail across scale really nicely. Like with some of the new time domain EM technology, we can tow these systems behind boats, behind ATVs, cover large areas, see deep, and and characterize the same properties we can with electrical techniques that can get very fine scale and high resolution. So we can start to stitch together measurements that are collected at different scale with different resolution. So I'm very excited about those prospects.
Great, thanks, Fred. So I'll segue from that, into sort of new modeling technologies. So we talked about new characterization technologies. This morning, I was on another workshop call with the Department of Energy. It was called, workshop is called Artificial Intelligence for Earth System Predictability. And the plenary speaker this morning was a climate scientist talking about that the primary challenge in climate sciences was understanding multiscale interactions, very much like what we have here in the subsurface. But he talked about using machine learning and AI approaches to approach that problem in a novel way. So my question to the panel is, do you see any roles for machine learning or other emerging modeling technologies to resolve scale challenges that in the subsurface that are associated with multiscale heterogeneity?
So I could share, I don't know if this is a scale challenge or more of a computational challenge with nuclear waste performance assessment, where you have a large repository. You have thousands of waste packages sitting in there, and they're all distanced appropriately, so the heat load is appropriately distributed. And to model the diffusion of the uranium or whatever the radionuclides are in that canister or waste package canister, whatever you want to call it, out of it, in order to model each waste package with accurate fidelity, it's just impossible to do that for thousands of these at the scales necessary. And so Sandia National Labs has developed, they've studied, just a single waste form, and they've trained machine learning, PNNL model, K-nearest neighbor model to predict the flux from a waste form over time, and then they embed that into their larger performance assessment model. So they just use machine learning to basically as a source term, but then they don't have to run all those lower level models, and it's worked quite well.
I think in some way, I think that's pretty similar to the approach that the speaker this morning was talking about, where they were looking at cloud resolving models that they could run at very small scales, but they couldn't run them at computational scales, at global scales. They couldn't computationally run them. And so they had a nested sort of approach where they used machine learning in some way to translate the information from the small scale model to the larger scale. Any other thoughts on machine learning or other emerging modeling technologies?
Tim, I'm just curious about, with the multi-scale modeling work that you've been kind of advocating for a number of years now, if you're entertaining those same thoughts of, feed forward from the small scale to get fluxes at a larger scale and that type of thing using AI.
Yeah, definitely. So one of the applications that's interesting is we've tried to connect microbial metabolism models with reactive transport models for a number of years now, starting with I think an early paper in 2009 that first tried to do that. And the way we did that was through a lookup table because it was too computationally intensive to try to re-execute the microbial metabolism model, which is a dynamic programming, linear programming problem. To do that for every time step and every grid cell throughout the course of the simulation. So we pre-computed a set and had a lookup table. One of the uses we've thought of and actually worked super well is to train a neural network model on the inputs and outputs of the microbial metabolism model. So the inputs are the concentrations of your nutrients, the outputs are the flux rates. And you can then represent that really complex reaction network, which often has like 500 reactions in it, by a simple neural net. And that neural net could actually then go directly into your reactive transport model as your reaction model, which is kind of a weird way to think about a reaction model. But actually, I talked a little bit with Glenn about this idea. And we think it's feasible. So it's something we've demonstrated for some simple test cases. So that's one example.
Yeah, nice.
So one of the ways I think machine learning could be used is that data-driven approaches in general, well, unless your data are biased, which often they can be, may remove some of the biases that are sort of built into our physics-based models. If we have a physics-based model, we assume we know about the process, and often because of scale issues, that introduces some kind of bias. So I think machine learning or data-driven models can remove some of those biases, and by comparing the results of physics-based and machine learning or data-driven models, it can help us identify model biases. So one of the questions that I wanted to pose is sort of, can we identify situations, or do we think that scale effects, multi-scale effects, cause systematic biases in model predictions related to remediation effectiveness? And if so, how can we best identify and resolve those biases in our models? And I'll just start by throwing out an example. I know that, for example, reaction rates in the field are often lower than what we observe in similar batch experiments in the laboratory because of the mixed nature of the batch experiment and the poorly mixed nature of the field. That introduces often a bias in reaction rates that tends to be lower reaction in the field. So that's just one example. Is there other types of examples and any ways that people have to address those?
Well, this isn't my my forte, but I am intrigued by process-guided machine learning, where you have one or more physics-based models that the machine learning is using, and then essentially correcting, much like a time series model, you know, has a predictor step and a corrector step, or a prediction and an update based on new data. The machine, you know, we can use these machine learning models using something very complicated for physics now, not just an ARIMA model or some transfer function model, but something incredibly sophisticated like pFlowTran, but then correct it based on new data at every step, and hopefully correct for those biases. I'm very excited by that. It's going to, I think, require a change in our thinking, our philosophy around our models, because we trust them and we like mass balance and conservation and all these things coded into them. And that's not going to be true with these new predictions if we start using machine learning, and that's going to be a change in our thinking as scientists.
Yeah, that's a good point, Fred. I think the session I went to this morning at the DOE workshop, the second speaker was someone you might know from USGS, Allison Appling. She presented that kind of idea where you combine, you know, you have knowledge informed or physics informed machine learning approaches. And the interesting point she raised is that how forceful are you in enforcing the kinds of ideas we embed in our physics-based models on the data? Can we actually do that in a way that maybe we use a lighter touch, right? We enforce certain things we know, like conservation laws, but many of the closure approximations that we use are not so well known, and maybe we're a little lighter on those, right?
Yeah, I think we're very amenable to admitting that we don't understand permeability structure or other geologically controlled parameters in the subsurface, but we often assume our boundary conditions are right, or the physics is right, and other things that might not really be right.
Well, I think we should kind of also consider that modeling is, it should be a sort of iterative process, right? So, you know, for many remediation problems, you know, we can get away with, you know, simple pump and treat systems until we get to the point where we're down to sort of a recalcitrant phase. And then we have to rethink, what are we doing wrong? What are we missing? You know, is it the heterogeneity? Is it some, you know, chemistry effect that we didn't consider in the simplified model? So there's an iterative element to this. And, you know, so I think it's always going to be that way. I don't think machine learning is necessarily going to solve that part of the problem. So.
Good point. Yeah, thanks, Mark.
Yeah, I mean, remediation is not my field to be, but from my point of view, I mean, what we can use machine learning is to establish new governing equations. That's like a new field that's coming out from machine learning. So basically, you can check your physics by using machine learning and basically extract governing equations that you previously couldn't or weren't able to do so. So that's like work done by I think it's Professor Karkidakis from Brown University. So this kind of approaches, and also I know that especially in petroleum engineering, where they have phase flow through porous media, and they're basically upscaling Navier-Stokes equations to Darcy's flow and try to see what's going on in there. They are now trying to do convoluted neural networks, the CNNs, to basically extract the images directly from there and then establish what's the porosity and what's the flow rate and the spore scale parameters and directly plug them into the Darcy's law. This is what I saw lately going on in there. And also they're trying now to do for the boundary conditions, for which we are not sure what's going on. I mean, we have standard set of boundary conditions, at least in my field. There is not many boundary conditions. It's a standard set. We have Neumann and that's basically it. But you can use basically machine learning to apply the boundary conditions that are more realistic in the real world. So this is where machine learning can help us. But yeah, I agree with you. Machine learning is not end all be all, because you still need to be careful with machine learning, because people tend to use it for everything, and then basically it's basically using an atomic bomb to kill a cockroach. Sometimes it's just it's not going to work, but at least they'll try. So yeah.
Yeah, thanks for those thoughts. So yeah, I agree. Some of the work on actually understanding physics or developing new physical representations through machine learning is really interesting. And Alex Tartakovsky did some of that work here as well before he left. He's now a professor in Illinois. And you mentioned Karniadakis, his group at Brown is really good at that. So, all right, well, I think we're about out of time. I'm going to turn it back over to Nick. We have 2 minutes. Nick, do you have any parting comments or thoughts?
Oh, I really enjoyed all the discussions, Tim and Fred and every presenter. It was a great session, and I appreciated very much all the work done here. The topic of applying machine learning is something that it comes in my mind every day as well. I am part of this workshop as well, Tim, and I was attending a couple of sessions last week, and they were all very interesting in terms of using machine learning in our fields. So thanks again, guys. It was great. We are very happy with the way that this session unfolded. So we will be moving. These are just my ending remarks. We are asking everybody to join us tomorrow. We have a very great program for tomorrow. Tuba City case study starts first at 6 a.m. Pacific Standard Time. Then we have a panel discussion on environmental justice in the context of environmental remediation. And then we have a technical session on environmental sensors. So it's a full day again of great case study, a great panel discussion, and then finishing again with a technical session. Thanks again for attending today's meeting. And I hope every one of you, I hope to see every one of you tomorrow. Have a great afternoon and evening and night and morning everywhere you are. Thanks again.
Thanks, Nick.
Thanks again to all the speakers.
Thank you.
Thanks again.
Okay, I think it's just us now, but we lost Nick.
Should we stop the recording?
Oh,